Damn, dude. That's the idea. Oh, okay. Because that's big. That's cool. That's cool. The you know, you'd really have to think about your routes and stuff. Man, this game has so much potential, dude. There's so much potential. That's really freaking cool, actually. That's really cool. Yeah. Yeah, hey, just watch your language when you're in here, Warrens. I try to keep everything clean during the day. That's 1 kilometer per player. That's pretty cool. Alright, dudes. Okay, I'll be back in a second, and then we'll start up Space News. That was fun. We got Space News, and we got some racing. Space News probably going to begin at the top of the hour, but yeah. And then we got some racing after that. We got a NASA press conference to listen to about SLS, and we'll go from there. Went too far with the hype. No, it's sometimes exclamation is warranted, but yeah, just no, like, I'm with you. Also, like, okay, that's pretty neat. Anyway, I'll be back here momentarily. Let me put on a video. Put on a video for everybody here. Oh, and the Crew 4 flight readiness review is going on right now. Jeez. Okay. Here, hold on. Yeah, passenger trains would be really cool. Hello. No, all right. Passenger trains would be really neat. Can you imagine? That, yeah, that's a big, I'll be honest, that's a big scope for the game, so we'll see. Give me one moment. Trying to find a video. Here we go. All right. Okay. I'll be back momentarily, and we'll go from there.
Contact light. Okay, engine stop. APA at a descent. Mode control both auto. Descent engine command override off. Engine arm off. 13 is in.
We copy you down, Eagle.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
And we're getting a picture on the TV. There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail. Okay, Neil, we can see you coming down the ladder now.
Sunday, July 20th, 1969. Around the world, nearly 1 billion people watched this moment on television as the first man from Earth prepared to set foot upon the moon.
At the foot of the ladder, the lamb footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the lamb now. That's 1 small step for man, 1 giant leap for mankind.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
All that we have accomplished in space, all that we may accomplish in days and years to come, we stand ready to share for the benefit of all mankind.
As we explore the reaches of space, let us go to the new worlds together, not as new worlds to be conquered, but as a new adventure to be shared.
Since the earliest time, man has imagined this moment, the moment when his fellow man would make the first journey to the moon. Now the time had come. In the 6th decade of the 20th century, the ancient dream was to become a reality. The flight of Apollo 11 was the culmination of many years of planning, working, building, and testing. Thousands of people had contributed toward this day of accomplishment. The great Saturn V rocket and the complex Apollo spacecraft had been assembled together and moved to the launch pad. The equipment and techniques and personnel had been proved in earlier missions, and now they were ready. The astronauts chosen for this mission had flown it many times in ground-based simulators. They had all been in space before. They had trained carefully and well, and now they too were ready. Astronaut Michael Collins would pilot the Apollo command module. Astronaut Edwin Aldrin Jr. would pilot the lunar module. And astronaut Neil Armstrong would serve as mission commander. Armstrong would be the first man to step upon the moon. July 16th, the day had come. The moon awaited. The men rose early, ate breakfast, and dressed in their spacesuits. Other astronauts had made this journey to the launch pad, but never with such anticipation. 9:32 a.m., July 16th. Three hours later, the Apollo command module moves forward to extract the lunar module from the third stage of the launch vehicle. Both are moving at more than 17,000 miles an hour. Docked together, they will sail 250,000 miles across the sea of space and into orbit around the Earth's nearest neighbor.
Oh, loud and clear now, Mike, and we understand that you are docked.
During the 3-day journey to the moon, the astronauts kept busy. Checklists, navigation and observation, housekeeping. They must work in a weightless environment, keeping their spacecraft and themselves in good condition. Data must be collected and reported. Experiments must be performed, including photography both inside and outside the spacecraft. Because of the film speed, these actions appear faster than they actually were. July 19th. Apollo 11 slows down and goes into orbit around the moon. The bright blue planet of Earth now lies 238,000 miles beyond the lunar horizon. Astronauts Armstrong and Aldrin, now in the lunar module, separate from the command module. Astronaut Collins remains behind. Preparation for the lunar module descent to the moon now begins. The command module assumes the new name, Columbia. The lunar module will be called the Eagle. From Columbia, Michael Collins' camera sees bright rays of the sun reflecting patterns of color from the surface of the Eagle. In this strange metallic bird rides the ancient and endless dream of all mankind. The command pilot can see detail which his camera cannot record. The 4 landing pads of the lunar module are fully extended and locked in place. The Eagle is poised and prepared for its descent to the lunar surface. The moon landing craft rocket engine fires to slow it down and to place it on the pathway to the landing site in the Sea of Tranquility. There is tension and caution as the Eagle flies lower. Warning lights blink on as the computer tries to keep up with the demand for control data, but the status remains go.
Eagle, we got you now. It's looking good, over.
Roger, copy.
Eagle Houston, after yaw around angles, S-band pitch, -9er, yaw, +18. Roger, you're a go to continue power descent. You're a go to continue power descent.
Altitude now 21,000 feet, still looking very good. Velocity down now to 1,200 feet per second.
You're looking great to us, Eagle.
Give us a reading on the 1202 program alarm.
Roger, we got you. We're going at alarm.
Good radar data. We're now in the approach phase, everything looking good. Altitude 4,200.
Houston, you're a go for landing, over.
Roger, understand. Go for landing. 3,000 feet. Program
Copy.
alarm.
Altitude 1,600. 1,400 feet, still looking very good.
700 feet, 21 down. 33 degrees. 100 feet down at 19. 1201. 1201.
Roger, 1201 alarm. We're go, same type, we're go.
Altitude, velocity, light. 3.5 down. 220 feet. 13 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down.
60 seconds.
Lights on. 6. Down 2.5. Forward. Forward. That's 40 feet down 2.5. Picking up some dust. 4 forward. 4 forward. Drifting to the right a little. That's okay. Contact light. Okay, engine stop.
We copy you down, Eagle.
Tranquility Base here. The Eagle has landed.
Through the window of the Eagle, Armstrong and Aldrin see what no human eyes have ever seen before. Their spacecraft casts a long shadow across the undisturbed dust of centuries. 7 hours after landing, after careful preparations for later ascent were completed, Armstrong opens the Eagle hatch and begins his climb down to the surface. The first footsteps on this strange new world must be taken cautiously. The moon has only 1/6 the gravity of Earth. The nature of its surface was still unknown.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Once on the surface, Armstrong scoops up a small sample of lunar dust and rock, precaution against the possibility of an emergency takeoff. According to plan, astronaut Aldrin now descends from the Eagle. He and his equipment would weigh 383 pounds on Earth. Here, they weigh about 66 pounds. For a brief moment, the first men on the moon stand and look at the stark, lonely landscape around them, an experience which no one before them can share. But there is much to be done in the limited time which they can stay on this airless, cloudless satellite of Earth. This sheet of metal foil traps and holds particles from the sun, the so-called solar wind, or barrage of solar energy, which constantly strikes the moon's surface. Results of this experiment will be taken back to Earth to reveal new secrets to anxious scientists. An American flag is left behind on the moon, together with medals honoring American and Soviet spacemen who lost their lives in earlier space tests, and a small disc carrying messages of goodwill from 73 nations on Earth. A plaque on the lunar module reads, "Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." Through a specially made television camera, viewers in many nations on Earth were able to watch the astronauts as they walked and worked on the moon. Despite the bulky spacesuits and the backpacks containing oxygen, temperature control, and communications equipment, the Apollo 11 crew found they could move easily about the surface. Because there is no wind or rain on the moon, these footprints will remain for centuries. In addition to collecting rock and soil samples, the explorers leave behind a seismometer. This highly sensitive device would send back valuable information on external meteoroid impacts, as well as internal lunar movements. A 100-prism laser reflector would help man to measure the exact distance from Earth to Moon to an accuracy of 6 inches. These were the first of many experiments which will be taken to the Moon to provide man continuing and increasing knowledge about the Moon and the vastness of space beyond. After 2 hours and 31 minutes, the first lunar explorers had completed their research on the Moon. A night of rest in the lunar module, countdown preparations, and they were ready to come home.
Tranquility Base, Houston. Guidance recommendation is pings, and you're cleared for takeoff.
Roger, understand. We're number 1 on the runway. 7, 6, 5, work stage, engine arm ascent. Beautiful. Very smooth. Very quiet ride. There's that one crater on there.
Discovery, going throttle up. 1,000 feet high, 80 feet per second vertical rise. Eagle Houston, you're looking good at 2. Ping, zags, and misspin all agree.
I'm going right down US 1.
Eagle Houston, going right down the track. Everything's great. Horizontal velocity approaching 2,500 feet per second. Roger. Some 120 miles to go until insertion.
July 21st. The Eagle and its 2-man crew lifted off the Moon perfectly and climbed slowly to rendezvous and dock with the mothership, Columbia. While Armstrong and Aldrin explored the Moon, astronaut Collins had kept a long and lonely vigil in the Columbia. The approaching Eagle was a welcome sight. Later, the 3 men would share their reflections on this adventure with the world.
I believe that from the early space flights, we demonstrated a potential to carry out this type of a mission. And again, it was a question of time until this would be accomplished.
I think it's a technical triumph for this country to have said what it was going to do a number of years ago, and then, by golly, do it.
The relative ease with which we were able to carry out our mission, which, of course, came after a very efficient and a logical sequence of flights, I think that this demonstrated that we were certainly on the right track when we took this commitment to go to the Moon.
I just see it as a beginning of a new age.
Once again, the bright blue planet of Earth rises over the lunar horizon. For those who had witnessed man's landing in the Sea of Tranquility, the moon would never again appear quite the same. July 24th, dawn in the Pacific. Apollo blazes across the heavens, coming back to Earth at 25,000 miles an hour. President Richard Nixon, who had talked with the astronauts by telephone while they were on the moon, was waiting aboard the recovery carrier to welcome the returning voyagers. The president later expressed the nation's response to this historic mission.
Some way, when those two Americans stepped on the moon, the people of this world were brought closer together. That it is that spirit, the spirit of Apollo, that America can now help to bring to our relations with other nations. The spirit of Apollo transcends geographical barriers and political differences. It can bring the people of the world together in peace.
To protect against any possible lunar contamination, the astronauts put on airtight special garments before coming aboard the rescue ship. They transferred directly from the helicopter to a mobile quarantine van, in which they would be flown back to the Manned Spacecraft Center in Houston, Texas. July 27th. The journey was ended. They were home again. Ahead lay 3 weeks of isolation, medical tests, and mission debriefings. Then visits to major cities of America and abroad. The details of their unique mission would be relived and remembered so that others might learn what they had learned, and that future travelers in space might build upon their experience. The rock and soil samples brought back would be examined and analyzed by scientists in many lands. They would reveal new insights into the origin and the age and the composition of the moon, and perhaps new knowledge of the Earth as well. Already experiments left on the moon were sending back revealing new information. The mission was successfully completed. The Eagle had landed the first men on the moon, and Columbia had returned them safely to Earth. Wherever man journeys tomorrow across the ocean of our universe, history will remind him that Apollo 11 was mankind's first encounter with a new world.
Ding! Space news time. Whew. Okay, welcome everybody. Oh, Master Payne, we are pleased to have you in our city, including that man you just hit. Welcome. All right, so we're hell yeah. All right, glad you could chime in. Yes. All right. Okay, so we're going to start off with the Artemis 1 wet dress rehearsal status update. This was a press conference from a couple hours ago, and I want to listen to it. It's 48 minutes. So, let's jump right in. Let's not jump right in. I'll do you one better, Chad. Did you know that the whitest kids you know get their name from EJ? All right. All right. All right.
It's the track right here. It's real early in the morning, Saturday morning, but I'm awake and I got a boombox, yo. Let's wake up your neighbors. Time to wake up your neighbors. Let's wake up the neighbors. Time to wake up the neighbors. It's 8 o'clock in the morning and your neighbors are upstairs snoring when they should be up enjoying the day. Go to your stereo and here's the track to play. Let's wake up your neighbors. Time to wake up your neighbors. Let's wake up the neighbors. Time to wake up the neighbors.
Okay, that's enough.
Center. To advise you that today's call is being recorded. If you have any objections, you may disconnect at this time.
No, I can listen to Robert Parker.
I would now like to turn the conference over to Tiffany Fairley. Thank you so much. You may begin.
Thank you. Good afternoon. I'm Tiffany Fairley with NASA's Office of Communications. NASA's third wet dress rehearsal attempt with a modified test procedure concluded yesterday, April 14th. The test focused on using the ground systems at Kennedy to load propellant into the Space Launch System's rocket core stage tanks with minimal propellant operations on the upper stage. The rocket remains in a safe configuration as teams assess next steps.
All right, I'm going to shut up,
provide
guys.
opening remarks and provide an update on the path forward for the Artemis 1 wet dress rehearsal are Mike Serafin, Artemis 1 Mission Manager, NASA Headquarters, Charlie Blackwell Thompson, Exploration Ground Systems, Artemis Launch Director, NASA Kennedy Space Center. And we'll also have questions available for Greg Horvath, Exploration Ground Systems Chief Engineer, NASA Kennedy Space Center. And we'll start with remarks from Mike.
Yeah, good afternoon. We appreciate everybody's time to continue to follow the Artemis mission as we get ready for flight. Since the last time we spoke, the team has done a tremendous job of rolling in the lessons learned and the technical information that we obtained from our attempt number 1 on April the 3rd and attempt number 2 on April the 4th. Prior to this third attempt that we had yesterday for the wet dress rehearsal, the mission management team met a day prior on Wednesday the 13th, and the focus of that discussion was primarily to resync the team headed into yesterday's test. Key topics of discussion included, closure of the actions and kind of updates on the procedural aspects of the wet dress rehearsal and what equipment inspections had been performed following the 2 prior attempts. Specific to the pad environmental control system and the fan outages that we had causing the scrub on attempt number 1, some updates to the cryogenic loading operations that we learned through attempt number 2, and then some procedural aspects to preclude another liquid hydrogen vent valve issue that caused us to scrub on attempt number 2 as well. Since that time, as you're aware, we had the issue with the interim cryopropulsion stage, or the upper stage's gaseous helium vent valve, check valve, and we modified the wet dress rehearsal procedure for that. So there were a number of changes that we talked about headed into the attempt number 3. And at the end of that meeting, the day prior to the test, we polled all the elements and all parties polled go. On the day of the test, we met with our launch director to talk about status and readiness for the attempt yesterday, and we had a very clean meeting. It took only about 25 minutes, and we had great support there from the range. The weather was great for the test, and the launch team and all of our support sites in Huntsville and Houston said they were ready to go. The rocket was ready, the spacecraft was ready, so we proceeded into the test. And during the wet dress attempt number 3, we encountered some issues with the cryogenic loading operations. Our launch director, Charlie, will walk you through that, both on the hydrogen and liquid oxygen side. And as the team worked their way through the cryogenic loading operations and got further into the operation than we did on our prior attempt and gained new technical knowledge and new technical information to prepare us for flight, we encountered a liquid hydrogen leak, or an LH2 leak, on the tail service mast unit. The tail service mast unit on the LH2 side sits on the deck, the zero deck of the mobile launcher, and it's about 30 feet tall. And there's an umbilical plate that is on the ground side that provides the cryogenic fuel, in this case the hydrogen, from the cryosphere at the perimeter of the pad and up through the mobile launcher system. That umbilical plate provides the interface with the Space Launch System rocket to fuel the core stage. And it was on the ground side of that umbilical plate that we saw the hydrogen leak. And after troubleshooting it, the team decided to knock it off for the day, because when you have hydrogen leaks and you have ambient oxygen out there, you only need an ignition source to close the fire triangle. So it was a flammability risk, and we knocked the test off as a result of that. Following the wet dress attempt yesterday, the mission management team met again at 6:30. It was a fairly long day for the MMT. We took about 45 minutes to roll up all the information we obtained through the test, and we talked about the art of the possible moving forward. And we've got a couple of options in front of us. We're not ready to say exactly what the option is. It's been less than 24 hours since then, and folks had a pretty long day yesterday. I'm sure our launch director probably had the longest day, because she got up before us to prep for the tanking meeting, and then worked all the way through the day and was there with us at the end of the day when we had our post-scrub MMT meeting. But we've got a couple of options in front of us. We are preserving the option to reattempt a wet dress as early as next week. Thursday the 21st is kind of the earliest time that the team is comfortable with doing that. We are aware that our commercial crew partners and friends that are going to be over on Launch Complex 39A are setting up for a launch attempt on the 23rd to launch Crew 4. Obviously, there's some coordination that we will continue to do with our range counterparts and our commercial crew and commercial LEO friends, and we're going to stay in close contact with them as we get smarter on our path forward. So that's pretty much my opening comments in our adventures in cryo loading and our readiness. But as was said earlier, the Mega Moon rocket is fine. All the issues that we're encountering, I would say, again, are procedural and lessons learned, with the exception of this ground umbilical plate that we've got to go figure out where the leak is, and we've got a couple of options that we're looking at there. So with that, those are my opening comments.
All right. Well, thanks, Mike. Let's see. It's Charlie Blackwell Thompson here, Artemis Launch Director. Hello, everyone. Thank you for your time today. I want to start off by saying that I'm really proud of the work that our team has accomplished and that we continue to do as we get through wet dress rehearsal. Yesterday and throughout the course of the countdown, which started on Tuesday afternoon, we continue to listen to the hardware. We continue to learn as part of this process, and we will continue to do that as we work through the remaining ops of wet dress. To start off, our call to station started right on time at 5 p.m. on April 12th, on Tuesday, and the teams worked through the procedures in configuring the flight hardware and getting us ready for tanking. And as Mike described, we got into our tanking brief yesterday morning. I had to think about that for a second. Got into our tanking brief yesterday morning, and really we were all systems go. We did experience an outage of gaseous nitrogen from the off-site supplier just as we were getting ready to begin our tanking operations, and so that set us back a little bit in our propellant loading timeline. Once we reestablished the supply of the GN2, our team started the operations to load liquid oxygen into the rocket's core stage. While loading liquid oxygen, or LOX, as we like to call it, the teams we encountered a similar issue to what we had during Run 2, where we had a temperature at the inlet that was showing a little warmer than we expected, and so our teams took a moment to go off and reassess the situation, and came up with an alteration to our plan, and put that into work, and we got right into our loading operations on the LO2 side of things. So shortly after we got into that operation, we began to look at the hydrogen side of the interface. We had been very anxious to load hydrogen. As folks know, the hydrogen molecularly is very small, and at cryogenic temperatures, sometimes in the beginning stages of loading is when you will see a leak. We got through our slow fill operations. Everything was nominal, had no issues. And when we transitioned to fast fill, which you will see an increase in pressure as part of that loading operations, we did detect a leak on the tail service mast on something that we call the purge can, or the purge canister. It's actually on the back of the ground side plate, and we can talk about that a little bit more in the questions, but we did see a leak there. We had a couple of different contingency scenarios or contingency plans that we can put into place or utilize, and we did that, but it did not resolve the leak. So we went ahead and safed that operation, got into our stop flow and into a revert, and decided that we would move on to the upper stage chill down operations as we had described in our previous press conference. We did that. Everything worked pretty much as expected. We continued to count down to the T-minus 10-minute hold, and as part of that T-minus 10-minute hold, we were able to not only accomplish the core stage LO2 load to just about halfway, about 49%. We did get the core stage LH2 slow fill as described, and then the upper stage chill down. We also did our flight safety system testing. Our range safety system testing was completed. We did first motion checks. We had our booster DFI checkout as well. We did our commanding with the Johnson Space Center. Our Dolly Lou operations were all worked. We did our tanking outer mold line scans. Those were completed. We did some of our guidance and navigation checkout, the Orion comm system checkout, and we were also able to demonstrate a number of our contingency procedures. So while we did not get all the way through the planned activities, we certainly accomplished quite a bit. So after working through that, and as I said, getting down to the T-minus 10-minute hold, we decided to end the day as Mike described, knowing that we would not be getting into the terminal portion of count. Again, the teams did an excellent job in accomplishing the objectives as briefed, and so we really saw very good performance across the flight systems, and again on those things that on those activities that we accomplished, we didn't have any significant issues besides the leak that we're going to talk about a little bit more in detail in just a second. So after calling it a day, we got into our drain operations and got into our purges overnight. This morning we began working up our troubleshooting plans for how to go assess the situation, and then also getting the pad opened up and starting to get back configured. So this is on the LH2. The LH2, there's a, and I'm sorry you guys can't see my kind of my hand motions here, but you've got the LH2, you've got a flight side plate and a ground side plate, and it's really what I call the back side of that plate. There's a purge canister there. The good news is that there's only a few things in that purge enclosure, and there's a couple of discrete penetrations there that we think could be the culprit or could be the cause of the leak. And so we'll go, what we're setting up to do now is we're getting access. We have access stands in the VAB. We currently have those, they're at the pad. We had them taken from the VAB to the pad this morning. And once we get the mobile launcher zero deck configured, we'll lift those up, get them into place, and we'll begin assessing those areas of the TSMU and taking a look at what we think the issue might be there. So the team's developing a troubleshooting plan. They got together this morning to look at these particular areas that we think could be the issue, how we get access to them, how we troubleshoot them, and then what the forward plan is. So I think that's where we are right now. And then while we're doing that, we'll also be replenishing commodities, preparing our timelines and our procedures to get ready for the next opportunity.
Thank you so much, Charlie. We'll now begin with the question and answer portion. Please remember to stick to one question and identify to whom it is directed. If we have time, we'll allow reporters to ask a second question. You can enter *1 on your phone to be entered into the queue at any time, and you can enter *2 if you'd like to be removed from the queue. Your phones are now on mute, and the operator will open your mic when we're ready and close your mic after you've asked your question. Again, we ask you please stick to one question. Shortly after we conclude, you can listen to a replay of this teleconference online. And we'll go ahead and begin with Marcia Dunn with Associated Press.
Yes, hi, for Mike. I'm just wondering if one of the options under consideration is, given that there is a launch coming up on the pad right nearby, just going right back to the VAB, replacing the valve in the upper stage, taking care of any other issues, and then going back to the pad. Is that under consideration at all at this point? And if you do a complete top to bottom wet dress rehearsal, how much extra time in processing would that be? Thanks.
Yeah, Marsha, I'll take the first part of that question. Charlie probably has a better sense of the timeline, but in terms of what the troubleshooting plan is, we're kind of breaking it down into a series of kind of low-hanging fruit options, things that are readily accessible. We hope that, there's something that is fairly straightforward and needs to be adjusted or is easily resolved, and we can do that at the pad and do it in fairly short order. And then there are a couple of more invasive options, and we've got to weigh those against a whole host of considerations that include, putting additional just wind stress on the vehicle. The longer we stay at the pad, the more we stress the vehicle. It's 32 stories tall. Every time the wind blows against it, it creates a bending moment, and over time that adds up. We got to weigh that against environmental exposure out in the field, but then also the rollback to the vehicle assembly building to reattempt a wet dress rehearsal actually puts stress on the vehicle as well. So we've got a series of actions that we've asked the team to go off and provide data back based on the core stages experience, going all the way back to the Stennis Space Center and the Green Run hot fire test and the stresses that we saw it go under not only there in the test stand, but also during transportation and some of the activities here at the Cape. We've got a whole host of other constraints that we're looking at as it pertains to interfaces with the spacecraft, and we're going to weigh all those, and we've got kind of what I call a bucket of considerations that we need to all bring to the table. And we talked about what those were last night in the post-scrub mission management team meeting. And I think once we get a better understanding of what all the considerations are, I'll be able to better answer your question. And Charlie, I don't know if you have any feedback on the timeline as far as what it might look like.
I really think that it's hard to say specifically because I think it depends on the scenario. Certainly, there are options within the trade space. I mean, if we looked at our planned schedule from a rollout to wet dress, I mean that's somewhere in the 7 to 10 day range. If you look at what we just did as we rolled out for wet dress, but there are different options that could be in play there. I mean, you could certainly look at your schedule risk for launch countdown, and you could make a decision of whether or not you wanted to do a tanking prior to a launch countdown. I mean, we have a certain number of days that we can be at the pad before we begin to bump up against our range requirements. And so you could make a strategic decision to go utilize one of those for a wet dress or a tanking and do that, and then some days later decide to go launch. So I think it really depends on the scenario from, your rollback to your first, if you were doing a tanking test, a wet dress, or a launch.
Guys, do you mind? Can we play a game? Like, and you guys, honestly, just tell me, do you want to listen to the press overview like what we usually do, or can we try something? What I wanted to try is see if I want to see, we'll play a game out of this, okay? It's not bingo, no. What I want to try to do is answer the press's questions. And I want to gauge my answer to the actual answers to see how well I understand this. What I want to do, and then you guys can be the judge on whether I got it right. Do it. I want to do it. I think I got the chops. I'm wondering how good I am at this. We'll see. We'll see how good. We'll see how well I understand this. We'd like to see how much they are obvious. All right. Let's do it. I want to do it. I'm going to shut up during the question, and then I'll pause it before they answer, okay? All right. And yeah, if you guys drank every time somebody asked 2 questions, you would not be in a good spot. All right. And let's see how confident I am. Let's see. I think I could. I understand how the TSMUs work. I know the TSMUs because I'm a shuttle nutcase. I know exactly, well, not exactly. I know what they do. So they're having trouble with they had trouble because they flowed hydrogen too fast through the tail service mast umbilical. So this one is hydrogen. That's the hydrogen fuel line and vent line. There's 2 hoses. There's one in and one out. And then there's a capture can in there. That's that white thing right there. At least I'm pretty damn sure. Okay? And these have a bunch of other ground side stuff. There's pneumatics, electronics, HVAC, stuff like that for the core stage. It's all the electrical for the core stage. This one is hydrogen and all of its paraphernalia, and this one is oxygen. Over here, these are twin TSMUs. The tail service mast is this gray thing right here. That's the gray thing. It's a mast that's on the bottom of the rocket at the tail of the rocket. The TSM houses the TSMU. That's what this thing is. Tail service mast umbilical. The tail service mast umbilical carries the tail service mast umbilical carrier plate, which is that's the thing that they're talking about. There's a piece that's attached to the carrier plate, which is, once again, this is ground side. Anything on this side of that white plate right there is ground side. Anything that's on the opposite side is the vehicle, right? They're talking about a hydrogen catch canister in there to catch the gaseous hydrogen coming out of the vent line. But anyway, I think I understand this. I'm confident. We'll see. I'll let you guys be the judge, all right? 3 attempts, 3 scrubs. I don't know if we're going to make it for June at this point. Swishio, you pessimistic about something? No, come on, man. We'll see. Remember, you're only hearing about the bad. Did you listen to what Charlie said? What she said? She said that, look, there's 1 or 2 things with leaks here and there, but for every 1 to 2 things going wrong, we got 1,000 things that went right. I mean, I'm paraphrasing, but that's essentially what happened. Like, they got not HVAC, they got Orion communication systems figured out. They got core stage power figured out. They got developmental flight instrumentation recorders on the SRBs figured out. Booster DFI. That's a lot of stuff, dude. That's like 1,000 things per one of those steps. So there is a lot of stuff that went right. We're only hearing about the problems. So just remember to keep that into perspective. There's a million moving parts on this damn thing. And every time they test, it's like 1 or 2 things that go wrong. Now, don't get me wrong. With spaceflight, you have to be right. Do not leave anything to chance if you can help it. Sometimes you got to leave it to chance. I mean, eventually, you're going to have to hit the go button on the rocket at some point. But the idea is to be the most prepared for that, right? Chance favors the prepared. That's like, a mantra for spaceflight. Chance favors the prepared. The more ready you can be, the better. The more favorable success. Anyway, let's get to the next question. We'll see if your boy can answer it.
Thank you. Next, we'll have Bill Harwood with CBS News.
Thank you very much. This is for either one of you, I guess, but can you develop rationale to fly without ever fueling the ICPS in a test? And I'm asking that because, most of the problems you guys have had have been on the ground side versus the rocket side, but there have been issues, all the way through. I'm just wondering, could you get to a point where you could actually launch the rocket without ever fueling the ICPS? That's my question.
Okay. That's Bill Harwood for CBS News. Bill is a fantastic reporter. He is like top tier when it comes to reporting spaceflight stuff. No opinions, no nothing, just literally what is going on. He's very, very good, like old school good. So he asked the NASA team here whether they could do a full wet dress rehearsal without ever tanking the ICPS. Now let me explain. What the hell is the ICPS? So see this thing right here with the American flag on it? That's the interim cryogenic propulsion stage. It's SLS's third stage, basically. I mean, the SLS doesn't have 3 stages. The booster is technically the first stage. Core stage is stage and a half, or the second stage, and then anything that's on top of this checkerboard right here gets into space. So that's technically the third stage. The ICPS is a Delta IV derived upper stage. It's derived from the DCSS, Delta Cryogenic Second Stage. Cryogenic stage consists of 3 main components. The hydrogen tank, which is what you see right here. The oxygen tank, which is hanging from the hydrogen tank inside of this conic structure called the vehicle stage adapter. And then below that is an RL-10B2 with an extendable nozzle. It's the same type of rocket motor that Atlas uses in its upper stage. Delta also uses that. Now, why is this one called the ICPS and why is the Delta IV stage called the DCSS? This one is a slightly modified version. It's actually a little bit bigger than the Delta IV stage. Now, he's asking whether they can get through the wet dress rehearsal without ever filling this thing up. I'm going to go ahead and say that yes. Yes, they can. They can do that. Now, why? Why can they do that? They can do that because there's data on the ICPS because it's Delta IV derived. Delta IV first flew in, 2002? All right, cool. Delta first flew in 2002, right? And the 5 meter upper stage has been flying for the better part of 20 years. Yeah, the Delta IV actually has 2 different types of upper stage. There's 2 DCSSs. There's a 4 meter and a 5 meter variant. This is derived from the 5 meter variant. I'm going to say because the umbilical for the ICPS is literally a mirror copy of Delta IV's over on pad 37B. It's a mirror copy of it. It's called an ICPSU, interim cryogenic propulsion stage umbilical. It's one of those big swing arms that get out of the way before the rocket launches. Because it's derived from that, I'll bet you that they have data on it. So they know and they understand that behavior with the helium check valve going a little wonky because of all the prior Delta IV flights. That's my guess. Let's see if I'm right. All right, here's NASA's answer.
Bill, fundamentally it comes down to risk acceptance and what we consider to be an acceptable level of risk. So I do believe that there is a path forward, provided that we understand what the risk is. It would include a whole host of considerations, including the Delta IV Heavy flight history and the Delta Cryo second stage and the history of this particular flight element and what data we've obtained through the testing to date, that some of which is at the pad, some of it is in the vehicle assembly building, and some of it was done before the interim propulsion stage ever arrived at the Kennedy Space Center. And we would have to weigh all that and understand the risk and either agree to accept that risk or decide what the Delta work would be to get to an acceptable level of risk. We are not done with our flight test program or our ground test program yet. and we're not ready to make that determination just yet.
I didn't listen to it on the break. I was watching the Apollo documentary with you guys.
Mike, is that
Okay, Charlie has to add something. Hold on.
we're not talking about a flight safety risk when we talk about that. We're talking about we do have launch commit criteria that if we were to make that decision, and I know that that's still ahead, there are launch commit criteria that protect you in the event that you were to have an issue during launch where you had an issue with
That's
loading.
correct,
I mean,
Crafty.
that would scrub your launch, but that would be the scenario that we would be talking about there.
Yep.
It's really a launch countdown scrub risk versus any kind of flight
Yeah,
safety
that's
risk.
a great
Interesting.
point, Charlie. that
Interesting.
There are
Interesting.
also,
Interesting.
Controls outside of the testing in place, and the launch commit criteria is probably the single best example of that.
Okay, if that was gibberish, they said that the ICPS fueling, and this is going to sound dumb when you say it in plain English, but the ICPS fueling is more of a countdown risk than it is a flight risk. They know that the stage will work as advertised because it's been flying for 20 years. That's a lot of data. That's a lot of data on the behavior of that stage and how it works. They're saying that the filling the stage up with fuel is the part that they're like, okay. And they said that all depends on risk. So, chance favors the prepared. That's actually really cool. That's really interesting. I guess I wouldn't have thought about it like that, They're breaking down subsets of risk. This is a risk during fueling operations with the ICPS having a hydrogen leak. A hydrogen leak, no matter where it is, will scrub all launches. And I talked about this yesterday, but I'll tell you guys again after the presser. Anyway, and Crafty, for what it's worth, interim cryogenic propulsion stage, it was supposed to be replaced after the first flight with the exploration upper stage, which is basically a bigger version of a DCSS, with the hydrogen tank being the same width as the core stage, and the oxidizer tank is the same width as the hydrogen tank for the ICPS. It is a bigger upper stage, and it has 4 RL-10s in it instead of just 1. It's a really, really good upper stage, but the reason why they ended up not going with that is because NASA's SLS has basically had a trickle budget the entire time. It's like an IV drip budget instead of like drinking a whole cup of water. You have that water IV dripped instead. I don't know why the heck you'd do that. And yeah, it shows because parts of the rocket are taking longer to develop than other parts because they literally have to fund each part of the rocket on a year-to-year basis from the ground up, and the funding just kind of stays the same. Compare that to Apollo, which peaked in funding. It went up like a freaking tidal wave and then came back down because they developed everything at the same time, as opposed to just developing one piece at the same time. That's part of the reason why HLS exists in the first place, because there was no budget to make a lander for SLS. I know. Yeah, if that sounds dumb, you're right. Yeah, that's not a good way to do things, but that ain't NASA's choice either. To be fair, Congress agrees with NASA that they should do things differently, but that's another story. Next question.
Thank you. Next, we'll have Irene Klotz with Aviation Week.
Irene asks very good questions. She's good.
Thanks. Good afternoon. Probably this is for
Half
Charlie.
point.
The hydrogen leak signature, was it gradual or was there a sudden increase in the concentration of hydrogen in the tail mast? And could you describe a little bit about what data you can get without doing a tanking that will let the team know that the leak has been found? Thanks.
Okay, so that was a two-parter. I want to listen to it one more time. Hold on.
Is there a sudden increase in the concentration of hydrogen in the tail mass? And could you describe a little bit about what data you can get without doing a tanking that will let the team know that the leak has been found? Thanks.
Okay, so she asked two questions. She asked, the leak, right? Did it just pop up out of nowhere, or did it slowly happen? And then she said, is there any test that you can do to ensure the leak doesn't happen again? Okay, so I'm 1 for 1. Okay, 1 for 1. Let's get the second question here. So All right. Generally, when you're flowing hydrogen, guys, you run into a little bit of problems, okay? Anytime you're testing anything new with hydrogen, this has literally happened for every rocket that uses hydrogen ever flown. Space Shuttle, Atlas Centaur, Delta 3 upper stage, Delta 4, it happens every time. Hydrogen leaks. You're never going to know until the first time you flow. Now, why? Why is that? What do you mean? They're just, what do they do? Not tighten the pipes down or something? Well, there's this thing about hydrogen. It's Charlie already said it, actually, in a little bit back in the interview. What she said was that it's very small. It's a very, hydrogen molecules are tiny. They're really, really small. And what happens is hydrogen is more or less stable. It doesn't leak when it's in liquid form. But the problem is that you're gonna the nominal temperature, right, that hydrogen exists as a liquid is near 0 Kelvin. It's like maybe 4 or 5 Kelvin. Like there's like a really, 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 really stringent gap for hydrogen to exist as a liquid. All right, 0.5 out of 1, fine, whatever. Okay, 0.5 out of not 0.5. I'm just freaking. There's a really, really small window that exists as a liquid. Okay, so what happens is if you have a pipe that's at ambient temperature and you're flowing hydrogen, which is like minus 400 Fahrenheit or something ridiculous, right? I don't know why I can never remember that exactly, but whatever. You're talking about a 400 degree change in temperature, or if it's Celsius, it's 200, right? That's a lot. So you have a warm pipe and you flow hydrogen through it, right? That hydrogen is going to want to turn to gas, right? Because it's exchanging heat with the pipe. The hydrogen's really cold, pipe's really hot. Hydrogen will absorb some of the heat and it'll sublimate into a gas, okay? The gaseous hydrogen is extremely hard to contain. It's very difficult. And once again, that's because hydrogen is small. The molecules are so tiny that they leak. They just go through the pipe. They will literally go through it. They will go around an O-ring. They'll go around a seal. They'll go around a bolt. They'll go everywhere. Unless you really, really make sure that your temperature is correct. If you even get the temperature off a little bit in one way or another, right? Like 1 Kelvin off, you're going to have a leak. So these fueling procedures that they go through, you know, I thought they would have probably had something figured out by now, and they probably have a good ballpark, but if you go to fuel it and you get a hydrogen leak, literally stop everything, or else your rocket will Hindenburg itself. Yeah, bad idea. So was the leak slow? I don't know. I would probably guess it probably showed the leak was probably correlative with the flow of hydrogen. Now, if they flow the hydrogen too fast, it's going to turn into gas too quickly, right? And then it'll leak. The pipe will pressurize, which is why they hit the pipe with I think they hit the pipe with nitrogen first to kind of hold the hydrogen and the gaseous hydrogen in place, and then they flow the hydrogen. I think that's what they said. Oh, nice, Bree. Okay. So I'll bet you the leak was correlative with the flow rate there. Now, the second part of that, what can they do to fix that problem? Honestly, just you got to go and look. You got to go and look at, inspect it, and make sure that that hydrogen, like, didn't, because like when it turns to gas, right? The gas can compress, and it'll force itself through like a seal or something. You got to make sure you didn't pinch an O-ring or something. So they'll be able to tell that if they do like a nitrogen test or something. Yeah, they'll be able to see it. In terms of like what they can do, they wouldn't flow nitrogen with people like looking at the thing. But they do have to flow nitrogen to fill it up again, right? Because they don't want anti-geysering. You gotta purge the pipe. You don't want to have like nitrogen and oxygen inside the pipe, then flow hydrogen in, because that's 2 out of 3 for making something explode. You need fuel, oxidizer, and spark. If you work on old cars, it's fuel, air, and spark. Create the conjoined triangles of success. No. So my answer to the first question is the leak was probably correlative with flow rate, so it probably was a slow leak. And the second part is that there is something that they can do to inspect it. It's just a hardware inspection. Just get a guy out on the pad that works on the umbilicals, and he'll know, or she'll know, you know. Anyway, let's see if EJ's right.
Yep, I can absolutely speak to that. And one thing I probably should have clarified when I was making my opening remarks is that In the cavity itself, between the flight plate and the ground plate, we did not see a leak. We actually saw this really on the back side of the plate. And so that's really good news for us because the access is much different and much easier. And what we saw is that as soon as we went into fast fill, we saw the leak go up pretty quickly. It wasn't a gradual leak. We saw it spike up. And I know you can't see my hands.
0.5 for 2.
But what happens is around the backside of that plate, there's like a purge shroud, and it's a fairly small enclosure. And so any amount of leakage in that enclosure, when you've got a sample line in there that's pulling that and looking at that concentration, I mean, it's a small volume, and so any amount of leak is going to send your concentration up pretty quickly, and that's what we saw. As soon as the teams went in to stop flow, we saw that leak just as quickly as it went up. We saw it come right back down. And so that was what we saw yesterday as during the test operations. And in terms of the path forward, and I'm going to pull Greg in here too because he's our chief engineer for the ground systems. In terms of the path forward and what we can do, there's a number of things that we believe that once we get access, we can go take a look at. As I described, there's a number of discrete penetrations into this area, and so the first thing is you want to go check those. And do you have anything that's loose or obvious? There's also some ambient leak checks that we can go do on the system, and then there's some other leak checks that we can do. This area is typically purged with helium. We could change the purge in there and run some helium
on the
through
nitrogen
some of these
purge.
other areas and use some of our HAZ gas detection equipment to go see where we're seeing leaks from. So we have a couple of tools that we can go that'll help us evaluate this particular area and these particular penetrations and figure out which one's really causing us the issue. Greg, any?
So I was kind of half right there. I was right in saying that they're going to send somebody out there. They're going to send the pad guy out there to go, the umbilical guy to go and make sure that he or she looks for anything wrong. Charlie also said that the backside of the umbilical is where the leak was, and the backside of the umbilical, I have a picture of it here. It's behind the TSM right here. Give me 1 second. It's this backside piece, and that's much more accessible, so they can go out there and physically inspect that thing. But I said they purged with nitrogen, they purged with helium, so that was wrong. But the inspection part I did get right, so I don't know. What do you guys think? Partial credit, so like 0.25 points awarded, so I'm like 0.75 for 2. That's terrible. A crane has gone up on the mobile launcher. But you didn't use the word penetration nearly enough, so no partial credit. How? I'm guessing the LN2 is not cold enough. Yeah, probably IPAC. Helium, similar. Well, not similar, but you know what I mean. Purging H2 is almost always with HE. See? Through me getting these questions or these things wrong, Novus, and checking myself, I learn. And see, now I won't forget that, which is great, because nothing teaches like failure. See? Yeah. 50-50? Okay, so I'm 1 for 2 cumulatively here. 1 for 2? I'll take that. That's fine. Is that rectangle on the right a camera? Yes. Actually, it's a mirror, Swishio. The camera's down here. It's looking up through like a telescopic box. The camera right here will melt. Actually, but also there is wires, so that could be a camera. I don't know. How they did it during Apollo was they just had mirrors. Still an F in public school. You can purge H2 systems with nitrogen, but you have to have some insulation to lower the outer surface temperature. Got it. Cool. We should do this with every press conference. All right. Next question. So I'm 1 for 2. Batting 500.
Anything to add on that?
You covered it mostly, Charlie. Yes. On the back side of that ground plate, we'll call it, there is a purge can. It's a 2-piece metal can that we bolt together. Within that can, we have several penetrations into the fill line and the bleed line. We don't think the bleed line's an issue because we weren't flowing through it. There was no pressure on it. and the signature of the leak happened when we transitioned to fast fill. We rapidly increased pressure in that line. The penetrations into the line, there's 3 of those on the fill line, and then we have a flange connection which has 2 gaskets with a debris plate between them. That's a bolted flange on the 8-inch line. That's another potential leak point as well. So like Charlie said, we do have access to that area at the pad with the access stands. Once we take that purge can off, we'll have ability to do a leak check. Now, ambient leak check is not the same as a cryogenic leak check at minus 423. So, a lot of times when we do leak checks, we don't see a leak at ambient, and then you get to cryogenic temperatures, and it does leak. So we're hoping to see something obvious with one of those penetrations into the line, and then we'll go from there as we get the data.
So, okay, so here's what he's talking about. So, right here, okay, there's 2 big pipes, and then those canisters that he's talking about is right here. I don't know why they blur the umbilical fitting, but whatever. It's the same one, well, it's almost the same as the shuttle, but it probably must have changed something. So he's talking about this line right here. This is the liquid line, I think. That's the liquid line, and then that's the return. That's the purge line. If you're having trouble remembering the temp of hydrogen, just say 420. You know what? I remember it in Fahrenheit. I don't remember it in centigrade. I just say minus 400. But 420 is a good way to remember that. That's cool. So it seems like, guys, they have those penetrations into the line. They're little pinprick holes in the line. You know why? Do you know what that hole? Do you know what those holes are? They're probably a filter to get gaseous hydrogen out of the line, because you're always going to have some hydrogen turn to gas. And my guess is that the liquid hydrogen will displace the gaseous hydrogen, and the pens in that line are only big enough to let gaseous hydrogen go out. And the canister is connected down here to the purge line, and the gaseous hydrogen goes into the gas purge line. That's my guess. I mean, that makes sense. That's a good way to do that, because you don't want to send gaseous hydrogen all the way up into the stage and then all the way back down. I see you're improving your penetration usage. So, I don't know. Half credit for that question. I would say I was more wrong than right on that one. I did get the hydrogen leak part right, but nobody's a tougher critic than yourself. I'm going to go ahead and say that I got that pretty wrong. There's a couple things that I got right, so I don't know, half credit, so benefit of the doubt, 0 out of 2. Hey, 0.5 out of 2. Okay, 0.5. Minus 5 for that one? Oh, come on! So, alright, I'm 0.5 for 2 right now, which is great. Not.
Up next, we'll have Eric Berger with Ars Technica.
Oh, boy.
Hi, thank you very much for doing this. I've got a couple questions. First,
you're
for
not
Mike,
thankful.
I think, is there a scenario in which you would actually launch the mission without completing a core stage wet dress test? I think you talked a lot about sort of the potential wear and tear on the vehicle and systems being out at the pad. And I'm just wondering if you'd get to a point where you would go without doing a wet dress test through terminal count. And then for Charlie, I think.
Melvis, you hear this? You hear this guy?
Can you tell me how long it's going to take to launch, how long you have to launch or roll back to VAB once the flight termination system is armed? I think I've heard something like 3 weeks, but I'd love a clarification. Thank you.
Okay, so the first question is, if they just keep running into problems, are they just going to say screw it and launch? The answer is a hard no. No way. You're not going to put that thing into a flight configuration unless you're sure that the fueling systems work. That's like when you go to fill your car up with gas, kind of instead of putting the nozzle right from the from the pump into the car, you just kind of point it at it and be like, maybe this will work. You don't want to do that. You don't want to have hydrogen leak while the vehicle's fully fueled. That would be very bad. So no, you're not. No, hell no, no way. You would not want that. I'm pretty damn sure of that. They would want it. So what they'll probably say in Swishio, I'll bet you that the guy is going to answer, not Charlie, the other dude. I forget his name. So he's going to answer it, and he's going to say no. They're going to want some baseline data on fueling operations, and they already have some from the green run, but you got to remember, the green run was on the test stand. This is on the pad. Two way different things. So they're going to, the vehicle can be tanked a bunch of times. We know that. We learned that from the green run. They can tank it like 15 or 16 times, and that's like full tanking cycles. So these partial tanking cycles aren't going to, they're not going to affect it too much. Eric didn't hesitate to burn NASA for their costs, but thinks they would have go fever with a first launch SLS and $1 billion rocket. Yeah, rocket guy. That's a pretty dumb question. Yeah. No, the answer is a resounding no. They will not launch that thing unless they get some baseline data on fueling operations. How NASA tests, guys, and they do this to retire risk. How NASA tests is they write a manual for how they think it's going to work, okay? And then they go out and they test the hardware right after that. Well, not right after that. They test the hardware. They actually follow the manual. And during these tests, like a wet dress rehearsal, or in the case of the space shuttle, it was the flight readiness firing, the FRF, they compare the data. They compare like, okay, is our manual right? Did we flow the fuels at the right rates? Is the vehicle at the right temperature for fueling? Did we purge something with helium correctly, right? And you ideally don't want to learn something during these tests because they're like a final exam. But rocket science is not an ideal thing, okay? There's a million moving parts on this vehicle. And literally NASA's gotten like 95% of them right. Off, like first try off the bat. There's only some flow, like hydrogen flow rate stuff. That's stuff that you really won't know. Like the manual can predict, right? You could do some quantification as to like how fast you should flow it, and then they have the data from the shuttle as well. But this is not a space shuttle. This is a different vehicle. It is shuttle derived, but it's not the same. You know, that's like saying a Tesla Roadster is the same as a Lotus Elise because they look the same on the outside. They are not the same thing. They look similar, but they're not. There's a whole new manual for this thing that's based off of the shuttle, but it's not the same. But that doesn't mean that also at the same time that they couldn't use some shuttle data as well. So Eric's first question was, are they going to try to just send it without it? No, you don't do that. Do not do that with a new vehicle. That is a really, 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 really negligent thing to do. Don't get go fever with a rocket that you've never launched. Now is the time to make sure that your manual for flying the thing is right. And don't get me wrong, you know, you ideally don't want to learn anything from the wet dress rehearsal. But if you do, you can figure out ways to make your manual better. And it will get better over time, but you still need a baseline. You need to baseline it somewhere. So they will not launch without tanking that core stage. No chance. Now the second one is he said, oh, excuse me, when launch? Basically, that was the second question. The second question, when are they going to launch it? He said 3 weeks. How long is it going to take to roll that back to the VAB, then roll it out for launch? Is that a 3-week time frame? Well, first of all, it's entirely dependent on the wet dress rehearsal. It's entirely dependent on how many things NASA learns. And, just because they fix one problem, that might make a problem somewhere else. And it's important to learn and understand this thing. Now is the time to go slow. I assure you, fellas, that SLS launches will not be this slow in the future. They won't take 11 hours to roll to the pad. It won't take them days to do all the tests, or weeks to do all the tests. It'll take days, and it'll take a couple hours to get out to the pad. The timeline entirely depends on how confident they are in the systems, and that comes from a baseline. Baselining the core stage and getting it full and going through the fueling and unfueling procedures and confirming that the manual that they have to fly this thing is correct is the most important thing. That is tantamount right now. That's more important than launching, because you can't launch without this data. Because say you go to launch it and you see something that's potentially anomalous. How the hell do you know it's anomalous? How do you know that's erroneous data? Your flight data recorder could be broken on the launch, and you wouldn't have known it unless you tested it on the ground, right? You got to be careful with this stuff. So I'm going to say the answer to the first question is no, they won't launch, and the timetable depends on how well the next wet dress rehearsal test goes. Let's see. Let's see if EJ's right.
Yeah, Eric. So on the core stage,
Maybe Swishio. It depends.
One of the I would say the primary objective of the wet dress rehearsal is to demonstrate the ability of the ground systems to perform these cryogenic operations with the core stage, and excuse me, our ability to demonstrate both of these commodities under flight-like conditions or ground test conditions is what we're really after here, and we have a very large vehicle, and we're flowing a lot of commodity, and we've got some really complex physics going on. I would argue they're PhD level physics. In order to complete the operation, we have to characterize those appropriately, and it's something that we need to go off and get enough data to show that we can complete these operations under the conditions that we will need on day of launch. That said, I mean it's possible that we will get enough data at some point that we'll be able to demonstrate or have enough confidence in this, and we'll just have to see what residual risk there is there. I wouldn't say that that's something that is really in the forefront of our mind right now, but it's something that that we could consider moving forward. I just don't see that right now as our primary objective. Our primary objective is really getting past this leak and getting into a wet dress.
2 for 3.
And Charlie, I don't know if you want to handle the time to launch question.
Yeah, so we do have, I believe what you're referring to is
actually, well,
we do
have
a requirement for the range for the flight safety system, and we do have a timeline associated with that, and that's 20 days.
I think I maybe misunderstood.
Next we'll have Andrea Leinfelder with Houston.
I think I misunderstood the second question. She said that the flight termination systems have a 20-day turnaround time. Now, guys, once again, don't like the press does ask some dumb questions. Like, okay, but like even with Eric, like, look, it's not. You have to. Sometimes they have to ask dumb questions to get it on the record, because how are you gonna know otherwise? There's no such thing as a stupid question. With that being said, like, having been doing this for a long time, it's really easy to tell who asks loaded questions and who doesn't. Like, Bill Harwood never asks a loaded question. He never does. He always just asks, it's always a question that's, as opposed to, like, oh, how much does this whole thing cost? Or, oh, when is it going to launch? As opposed to questions like that, because that's a loaded question. You don't know the answer to that question, so you're asking a question that they don't know. He always asks a question to learn something new about the vehicle. Those are the kind of questions that I like, because I understand, not me, like, oh, I understand it. No, that's not what I'm getting at. It's important to understand NASA's mentality when it comes to this stuff, and that's why I like doing this. That's why I think this is a good idea. I should do this more often. Eric asked, how long can SLS sit out there before having to go back for FTS changeout? 20 days. Okay, so I missed his second question, Rocket Guy. I assumed the question, so I missed it. So, I don't know, half credit, because missing the question doesn't, if you swing and a miss, dude. So, I would say instead of 2 for 3, I'm 1.5 for 3. So, I'm running at a 50% rate of being correct. I'm batting 500, man. It's not bad. That's not bad. All right, next question. L85 just got pushed. Net Sunday, excessive upper level winds. Okay.
Houston Chronicles.
All right, let's see. I'm not familiar with this person.
I would like to put this wet dress rehearsal into a bit of perspective. I'm not sure if this is a question for either of you, but I'm curious how it compares with the wet dress rehearsals for the Space Shuttle and the Saturn V rocket. Like, if you can describe how long those tests took and what type of issues were discovered, just so we can put this a little bit in perspective for readers. Thank you.
See, that is seemingly a stupid question, but that's not a bad question to ask, all right? That is a question coming from a place of ignorance, not willful ignorance. It's not a loaded question. You know, she wants to know, like, she's basically asking, have questions like this, have stuff like this popped up with other launch vehicles? The answer is yes, abso-freaking-lutely. Every vehicle has teething problems, no matter what. You can't predict the future. You can't make sure every single freaking thing is going to go right. That's a good question. So she asked how it compares to the shuttle in Saturn V. They're probably going to say something like the shuttle is, SLS is derived from the shuttle, but it's not the same vehicle, and it's going to have its own fair share of problems. They did run into problems like this during the shuttle program. Yeah, SDS-1 scrubbed on the pad on the first day because of leak problems. That did happen. That was, 41 years ago? Actually, 41 years ago within a day or two. Yeah, every vehicle has teething problems. They had this problem with the Saturn V. Saturn V was more flight-oriented stuff. They had pogo oscillations with the vehicle. Every new vehicle has teething problems. You can't predict the future. You don't know for sure if everything's going to go right until you actually go and, do it. So, it puts a super complicated process in terms of already flown vehicles, which is much easier for grasp for regular people. Yeah, Savvy, that's what I mean. This woman from the Houston Chronicle, it's a seemingly dumb question, but that's not a dumb question. That's actually a really smart way to put it. It's very eloquent because it seems simple. Like, she didn't throw any big freaking words in there. It's just, hey, how does this compare to the other vehicles? That's a smart question. Let's see if I get it right.
So let's see. I'll take a shot at this one, Mike and Greg. If you guys have any additional info, feel free to jump in here. So I have the honor of working with one of the engineers. He's actually on our cryo propulsion team that was around for STS-1, and so we were just talking about this week. How many tankings did it take before we got ready for launch? And I think the number was somewhere in the 5 to 6 prior to launch for STS-1. And so if you look at that in the context of kind of where we are, again, shuttle was a single stage vehicle. We're trying to load 2 stages, so you gotta get the core stage and upper stage. There are some complexities with that load compared to shuttle. And so I would say, putting it in context, I would say we're within family of our experience in the past for first time ops, is how I would characterize it. But Greg or Mike, if you want to offer.
The green run was the static fire can tab from 2020.
Yeah, Andrea, I would say we occasionally get to talk with some graybeards that are around from shuttle or the Apollo
nice.
Saturn time frame, and they will tell us that
graybeards. Awesome.
These systems are incredibly hard to characterize. You've got complex physics going on. You've got fluid dynamics, you've got thermodynamics, you've got flammability hazards, you've got cryogenic temperatures and structural stresses you're putting on it, not only from the weight of the propellant, but also the structural stresses come in because you're literally causing these very large cylinders to change shape because you're chilling them down to minus 280-ish degrees on one side and minus 450 on the other. So when you take into account all these stresses and strains and fluid flow rates, and you want to avoid having things like a geyser, which is a two-phase flow moment, and the thermodynamics that you're trying to stay within or avoid, and all the hazard controls and all of the other constraints and considerations in play, I would say we're in family. We've got much more advanced engineering models and techniques, and the ability to build precise pressure vessels using state-of-the-art welding techniques and that kind of stuff, so that the flight hardware is done quite well. It's really adjusting the two together that's been a problem for us, and I would say that again, history has shown it's been a challenge for pretty much anybody that's done anything of this magnitude.
Hey, points for me. Yeah 2.5 out of 4. 2.5 out of 4. I'll give it to you. All right, cool. I'm 2.5 out of 4, man. I'm above 500, baby. Boom! Hey, I said STS-1 had hydrogen leaks. I said that, and then Charlie said that. Come on, man. That's all. Hey, all right. I'm pretty happy with myself, dude. Come on, that's pretty good. Hitting 625. All right. Not bad. 3.14159, but don't do that to me. Because it's not time to eat pie. You eat pie when Artemis 1 comes back. That's later. All right. He said so many words, your odds were good. Shh. All right, let's keep going.
Next, we'll have Jeff Faust with Space News.
Jeff is awesome. He's right up there with Bill Harwood, one of the best in the business by a long shot. He's the guy that started literally spacenews.com. Yeah, Jeff is the best. He'll ask a good question.
Good afternoon. A question for Mike Serafin. You mentioned in your opening remarks you were looking at a couple of options, one of which was to try the wet dress again as soon as the 21st. Apologies if I missed it earlier, but what other specific options are you looking at right now in addition to trying the wet dress later next week? Thanks.
Well, Jeff asked one question, and basically he said the 21st is the next, but what other options are you exploring? Ooh. Yeah, that's not really an engineering question. That's something where you'd need, like... Yeah, I'm not sure I'm going to get this one right, but I'll guess. Mike's probably going to... Mike Serafin is the guy's name. He's... Yeah. I'll throw my hat into the ring, though. Okay, so let's think about this logically, all right? Let's look at a calendar here real quick. Get this out of here. He said the 21st was the next point. What other options would they be considering? Well, okay. I'm going to try to put this in simple terms. Artemis 1 can only launch in basically the 4th week of every month. Why? Well, the moon has to be in the right place, and the moon tends to come around every month to be in the right place. If the moon is in the right place, you launch it, capsule misses, it's not coming home. So generally, this is very generally speaking, there's a lot more orbital dynamics going on. There's a lot more, space is complicated. There's a lot more stuff going on up there. But generally, the last week of every month, you know, last week of April, last week of May, last week of June, last week of July, are the opportune windows when the moon is going to come around and be in the right place, because lunar cycles are, for the most part, every month, right? It shifts a little bit, right? So, knowing that, there's a launch window probably here, 25 to the 29th of April. There's no way in hell they're doing that. That's not happening. So, they wouldn't test on the 21st and launch on the 29th. Yeah, that was the answer to Eric's question. So, May is down here. The window for May, I believe, is like the 19th to the 26th. I think it's right here. So, and then the window for June is like 24, 25, 26, 27, 28, 29, 30. It's this week right here. If I'm remembering right, that's off the top of my head. I could be wrong. So, my guess, and once again, this is a hard question to answer because I don't work for NASA, all right? This is not so much an engineering question, but a timeline question. The timeline question is dependent on a bunch of internal things. So, Jeff Faust said, what are your other plans besides, testing on the 21st? Depending on that how well that test goes, right? That's probably what they're shooting for, if I had to guess. Depending on how that test goes, they probably could do it again in the 4th week of April, right? And still have enough time to make that late May launch window. Okay? My guess is that if it goes, if that thing's still out on the pad in 2 weeks, they're shooting for June. That's probably what's going on. If I had to guess. The other options would just refer to those launch windows. I don't think it really goes much deeper. Yeah, Rocket, probably, because I know more or less when the opportune windows are, because I've been reading that. because I'm trying to plan like summer vacations around rocket launches and stuff. So I've been looking into when's the opportune time. And don't get me wrong, the Saturn V had to do the same thing. They had to make sure the moon was in the right place. Not even as big, crazy Chad tier rocket as the Saturn V could just launch willy-nilly to the moon. You had to make sure of a couple of things. Like there's a couple of outstanding things that have to be right. One, you got to land on the moon in the daytime. Now, the moon does have a day-night cycle, but because the moon is tidally locked, days last like a week on the moon. Because the moon freaking... It's always... The same part of the moon is always pointing at Earth, so the days are very, very long. You do not want to land on the moon at night. Ask any Kerbal player what it's like landing on Mun at night with no lights. That's really difficult. That's a big one. The second one is honestly, and even before, that's before landing at the night part. You got to make sure the moon is in the right. You got to make sure the moon is in the right place. If it's not in the right place, then you're just gonna miss. It's like the target's over here. Let's shoot over there. All right. Oh, it missed. Oops. Does that sound like NASA? No. So I'm gonna guess it really depends on how well that test on the 21st goes. Let's see what happens. Let's see if your boy's right again. I did on the first try.
Yeah, so, the options are, again, it's really what are the low-hanging fruit options, things that are relatively straightforward, easy, obvious, that need to just be adjusted on this purge canister, or the penetrations that maybe there's an obvious leak source, and to basically rectify that. There are some more invasive options that require getting further into the hardware and potentially having to get into some extended troubleshooting, and then where is the most appropriate location to conduct that. I would say that's kind of the spectrum of what we're looking at, but there are other constraints and considerations that we're looking at that have to do with the pad environment, or if we were to choose to not do this work out at the pad, what we would be giving up or gaining in that case. So there's again a number of considerations there. I don't want to get in front of those decisions. We're not ready to make that decision. We haven't fully outlined all the options right now. The one that we're pursuing, I would say, with great vigor, is the low-hanging fruit option, and we'll let the team kind of come up with some other options here. Again, it's been less than 24 hours since we ran into this problem.
Okay, so it seems like I misunderstood the question a little bit, or maybe I read too much into it on that one. I would count that as not really correct. I think what Jeff was asking was, now that I've heard the answer, I'm pretty sure what he was asking is like, what's the next step forward, because you have another wet dress rehearsal on the 21st. What's the plan? And Mike gave him a response that basically said, well, we got to see what's broken, if anything. And depending on what's broken, it might take longer, it might take shorter. But generally we're gonna try to fix it as quickly as we can. That's it, but it might take longer. I don't know. I'm gonna call that a big fat 0. Yeah, because I was talking about what I focused on was after you fix it, and launch and testing windows based off of after you're fixing this problem. So I skipped a step. So that's wrong. That is incorrect on my part. So that's a big fat goose egg. So what am I at? 2.5 out of 5? Damn it. Hey, 50 is good though. 50% is good. You're half right. Yeah, honestly, I should be getting every single one of these questions exact. Every single one of them. I'm actually kind of disappointed, but hey, whatever. 50 is an F. And you know what, Savvy? A 90 is an F in spaceflight. 90% ain't gonna get you there. 99, 100% is gonna get you there. And nothing else. There's no, even getting an A, that's a failure in spaceflight. We're graded on a huge curve here. Thrust curves, am I right? All right.
Next, we'll have Ramin Skiba with Wired Magazine.
Hi, thank you. This is, I guess, a question for both of you. I just wanted to follow up on an earlier question. Would you say that, considering the complex physics involved and how these are in many ways new pieces of hardware, and there's a lot at stake with this rocket, are you still very confident about continuing, finishing the wet dress rehearsal test on the launch pad and hopefully launching in the next few months? Like how confident do you feel about the process at this point?
Confidence is a gauge in engineering, guys. They're probably going to give a non-answer to this. It really depends. Like, okay, so I know people are going to say, what do you mean it really depends, EJ? Well, it depends on how quickly, it's kind of a follow-up to the last question. It depends on how quickly they can figure this out. When they say it depends, right? It depends on understanding what the heck the vehicle is. In spaceflight, you build something. And there's no real way to quantify every single piece of behavior that vehicle does because of where rockets go. It's not like a car that's just going to be on the ground, all right? Where air pressure basically stays the same. Aerodynamics stays the same. Temperature is pretty much the same, except if, like, the sun goes down. There's not a lot of dynamic conditions. I mean, there is for cars, but rockets is a much more dynamic condition. You're changing temperatures. You're changing pressures. You're changing... the environment that the vehicle exists, where the second stage is and where the first stage is polar opposites. All right, you have 14 psi, 1 bar pressure down here with 70-degree ambient temperature, and then you go up there, you have 0 pressure with 0 temperature, and it is a complete polar opposite environment. So, it really depends. It really depends on understanding what the vehicle's going to do going through, like, the transition from down here to up there. They're gonna say it depends. I'm pretty damn sure. Final answer.
Yeah, Ramin, I would say the Mega Moon rocket is fine. The vehicle has performed really well. The only thing we're seeing on the flight side is this check valve on the upper stage. That is a relatively straightforward thing to go off and resolve. The other things that we've learned have been largely procedural or slight adjustments in the operation or the limit sets or some of the software triggers. Those are things that are relatively straightforward to go off and do. You just need a little bit of time to work through them and confirm that you're staying within the system constraints. And then this hydrogen leak, and that's on the ground side. So, I'm confident we're going to get there. If you want an exact date, I can't give that to you right now. It's really just we will be ready when we get through the test program. And we are, I can promise you, we are working hard to get through it. We are putting in some long hours to do it, and we will let you know when we know when we're going to set up for a launch attempt. I don't know, Charlie, if you have any thoughts on that.
Yeah, I certainly have some thoughts on it. I mean, there is no doubt in my mind that we will finish this test campaign and that we will listen to the hardware, and the data will lead us to the next steps, and we will take the appropriate steps, and we will launch this vehicle. As Mike said, I don't know exactly what that date is, but there's no doubt in my mind that we'll finish the test campaign and we will be ready to go fly.
Savvy, what do you think? I said it, but I said it differently than the way they said it. What do you think, chat? In a nutshell, they said the same thing that I said, but they said it differently. But it basically, you're not going to launch it before you're done testing. You got to test it. You got to test it to understand, and that's why it depends. It depends on how long the testing takes to know when they're going to launch. You got it? They just fluffed it? I'll give it to you? Okay, so what am I at? 3.5 out of 6? There you go, Sebby. Hell yeah. It depends on the data, that's right. Yeah, Blue. Yeah, I got it, man. Yeah, I got pushed again. To Sunday. Because obviously. Oh, shoot. It's okay. It should automatically be up there by itself, Dog Meat, just on a quick side note. Just make sure you don't select a switch or something because it'll delete the UI. Confidence destroyed yet? What am I at? 3.5 out of 6? 4 or 5 out of 6? What are we at? I was 3 point... What's my total? What's my tally right now? I'm sorry, I lost count. They didn't say it depends, so what, do you want me to phrase it in a question? Trebek would like, what, I gotta phrase it in a question? What is it depends? What is you wear depends? Got him. I think I was at like 2.5 out of 5, so more or less I got that question right, so 3.5 out of 6 is where we're at. Okay. Okay. Not great, not terrible.
Thanks so much, and we'll have time for a final question, and that'll be Micah Maidenberg with Wall Street Journal.
Hi there. I think this is a message for Charlie. Could you remind us which contractor was responsible for the umbilical where the leak appeared, and what sorts of communication, if any, you've had with that company about this issue? Thanks.
I think this gentleman is getting the nitrogen purge line systems confused with the canister. I'm. It's got to be Jacobs. It's got to be Jacobs. No Google. It's got to be Jacobs. Jacobs is the one that's putting this all together. Now, whether they built the TSMUs, I think the TSMUs are done in-house, Savvy, if I'm remembering correctly. That's a tough question. Yeah, that's not an engineering question. That's a tough one. Yeah, what company to blame? Yeah, I know. I think the gentleman's getting, because they had some problems with a commercial supplier of nitrogen. The commercial supplier flowed nitrogen too fast and it froze the pipe. But that's unrelated to this hydrogen thing. I'm pretty sure it's either Jacobs. Jacobs is the name of the company that operates SLS right now, technically. It's either, and Jacobs might be NASA in-house. NASA has a lot of shell companies out there. They do that for better benefits for their employees than the government and stuff. So there's Jacobs is like, there are sole contractors that there are companies that are started just to fulfill a NASA contract. Once again, so you get a better benefits package for the employees. They do that. I have that on pretty first-hand account. Like United Space Alliance was a company that existed from like 96 to 2011, and United Space Alliance was the commercial contractor that operated the shuttle. But they operated the shuttle basically in every capacity up until the point of launching it and flying it. That was NASA. So I would have to say Jacobs if I had to guess, but the umbilicals very well could be done in-house. Yeah. So we'll see.
And so let's see, it is our ground hardware on the ground side of the interface where we saw this particular leak. In terms of the manufacturer of that, I'll have to get back with you on that, unless Greg, you have information. Okay. Yeah, we'll have to get that for you. But the hardware belongs to the ground systems.
Yeah, it's EGS, so it's in-house.
Thank you all for joining us today. You can listen to a replay of this teleconference online by visiting the Media Resources tab at www.nasa.gov/Artemis-1 later this afternoon.
So, do I get points for that one or not? Because they didn't even know the answer technically, but I was pretty sure it was either Jacobs or in-house. But even Jacobs is NASA. Same thing. Yeah, non-appropriated something or other, Hellfish. Something like that. 0 points? I would say 0. It was a second guess, so maybe half credit? No. There's... It's not really a question. Yeah. I would say 0 out of 0. Okay, so out of 6 questions, I got partial credit on 2 of them, and I got 3.5 out of 6. That's not bad. That's not bad. I would really want it to be 100%, though. Some of the questions that I got wrong, I misunderstood. The hydrogen flow question, I got completely wrong. Completely 100% incorrect. Eric's second question, I misunderstood. So, I mean, it doesn't matter. Misunderstanding still end in failure in spaceflight. So, I'm going to be pretty tough on myself here. So 3-6 out of 6. How did you guys do? Who went along with me? Anyone? I don't think anybody did. Hey, that's not bad. I'll take it. It's not good. 3.6. Not great. Not terrible. I'm an engineer. I got nothing wrong. Well, I'm not, man. Jeez. I'm trying to get better at this. Yeah, Drader, yeah, right. Is it just me or is this model incomplete? Alright, so I have a pretty good fundamental understanding, but it's not totally right. RB, what's incomplete about this? Yeah, 50% is good in horseshoes and hand grenades. That's nowhere near good enough for spaceflight. It's for spaceflight knowledge. RB, what am I looking at here? Did you guys like that? Should I do that every time? I think I should. I think I should to gauge myself. RB, what do you... Are the runners open inside? This was scanned, RB. This is not... Yeah, no. There's no... No, there's no plenum in this. Yeah, I think we should do that to learn. Yeah, there's no... This was 3D scanned with LiDAR. Look, it picked up some casting imperfections there. In RB, in reality, that can cause performance decreases because you're making drag inside of the... You're making drag inside of the intake manifold, and that's not good for it. But yeah, this was just 3D scanned. It's missing some parts. Yeah, it's missing the lower exhaust plenum. So this is a dual plane intake manifold, RB. So you got two. There's 2 plenums. Down here will be another one of these, and these plenums will lead it to the 4 intake ports. 1, 2. That plenum right there. So what is this for? This is for Ford. This is for a Windsor motor. The distributor's up in the front. Yeah, Windsor motor. So, okay, if that's the case, you have 1, 2, 3, 4, 5, 6, 7, 8. So this right plenum will go to 5, 6, 7, and 8, and then the left plenum will go to 1, 2, 3, and 4. Actually, no, I didn't get that right. Excuse me. This plenum will go to 1, 6, 7, and 4. And then the other plenum will go to 5, 2, 3, and 8. You can see that from the pipes. But yeah, these should be passages right here, dude. There should be a passageway. Right there. Yeah, there's no inside of this because it's 3D scanned. So you have your intake ports here. 1, 2, 3, and 4. Well, this is 5, 6, 7, and 8. And then you have your head studs here. And then you see that? RB, do you know what that is? Nobody else answered. Do you know what 1, 2? Do you know what those are for? It's cross-hatching Cantab for aerodynamics. Like a golf ball. Same idea. oil drain from the heads. Oil doesn't go into the intake manifold, dude. It covers the valley where the oil is. Those are cooling jackets. That's for cooling purposes. You want to circulate, so check this out. Look. If coolant gets up into the intake manifold, it's going to open up the thermostat, which is what is right here, okay? And if the thermostat opens, you're going to start moving coolant around, right? So basically, when coolant gets up here, it goes right to this, and it opens the thermostat, and then that moves the fuel. The fuel circulates through the top of the radiator, out the bottom, back into the motor, back into the water pump, technically, and then into the motor, up and out. When the coolant system gets hotter, it'll go in here, and when it gets hot enough, it'll heat up the thermostat, and thermostat will open. Those are cooling channels right there for the engine. Yep. And then another cool thing about this is right there. Well, not a cool thing; it's just a thing. Right here is the bung, I guess, for the heater core. So this intake manifold is capable of having a heater core on it. The other one on a Windsor motor would be on the water pump. Yeah, I know these motors pretty well. So, yeah, this right here, the cross hatching that's going on there is for aerodynamics. They want the air to flow, and that it's the same kind of dimpling as a golf ball. Same thing. Yeah, they do that to make sure the air accelerates. Bung. Wait, so in a car the thermostat doesn't work based on temperature but on coolant pressure? Well, pressure is conducive to temperature, devious. The coolant system is pressurized. Oh, absolutely. When it's pressurized, basically the engine heats up the coolant system pressurizes, and it pressurizes behind the thermostat. The thermostat keeps the coolant in initially on a car, on an older car. I don't know how. I mean, I guess that a newer car would be the same, right? It keeps the coolant in when you're starting the motor up, so the motor warms up faster. Yeah, and so the system starts pumping water into the system, gets the system up to pressure, heats up the engine. When the engine gets to a nominal operating temperature, right? Because when the engine heats up, stuff expands and stuff seals. That's why you don't beat on an engine when it's cold. It's very bad for it. And then, the pressure increase is going to increase the temperature, but it increases the temperature to a point just before the coolant should start boiling at about 180 F or, well, approaching 100 C. And then the thermostat has a piece of metal in it, right? It's like a spring almost. And when part of the spring is exposed inside of the engine and the spring is attached to a valve, okay? So when the spring gets heated up, it expands and it opens the valve. Yeah, it's that simple. Doesn't need to be more complicated. If you take a thermostat from an old car, you hit the back with a blowtorch, the valve opens. Yep. And then, once your motor's up to operating temperature, the thermostat will open and it'll start moving coolant through. It'll start moving coolant around through the system, radiator back to engine, radiator back to water pump back to engine, and then back to radiator again. It'll start circulating to keep the engine cool, to keep it at that operating temperature. Yeah, it's pretty smart, dude. Pretty smart stuff. Thermodynamics do be like that. Yeah, RB, this is missing it's missing one of the plenums. So, fellas, on an intake manifold like this, okay? This is a dual plane. Basically, this is something that you'd use on the street because the engine won't be going to like super high revs. The idea is to pressurize in here. There's like a reservoir, okay? This is called an intake plenum. It's a reservoir of air. Basically, they want the air to be pressurized in here. Now, here's the thing, fellas. How the heck do you do that? How do you do that? How do you pressurize inside of the plenum? Well, the valves on the engine close, so air is being forced in technically when some of the valves are closed, right? So it will pressurize. But how do you do that? The top is open up. How do you prevent backflow through the carburetor? The engine's a vacuum. It creates a vacuum in there, just like a spacecraft, like where a spacecraft operates. Same kind of thing. There's a vacuum right here. All right, so when that thing opens, it sucks the air in and it maintains positive pressure in here, because you always want a reservoir of air. You want this part to be pressurized with your oxidizer, because when the piston opens, right, and that piston goes down, it wants to suck the air in. You want to get the air to force, you want to force the air into that combustion chamber, because the more air that you can force into the combustion chamber, the more performance you get. Jesus, 12-month resub. Because if you can put more oxidizer in there, you could spray more fuel. And if you could spray more fuel and more oxidizer, you make more power. It's the same case with rockets, same case with cars, same case with jets, same case with trains, everything. Anything that uses internal combustion. So you kind of want to, these plenums here are basically air reservoirs. And you want to keep them, you ideally want them pressurized. And the reason why this is split, right? The reason why it's a split, this is a dual plane, so there's two plenums in here, is because on the street, your engine's not going to like be revving like a race car, like all the way to red line. On the street, you want to get performance, right? And if you want to get performance, it's easier to pressurize two smaller plenums than it is to pressurize one big one to have the engine perform ideally like at a higher RPM. Yeah. Pretty cool, huh? Or you guys want to see something really cool? Check this out. So, if we look at a Corvette C8's intake manifold, let me see if I can find a picture. The Corvette C8's intake manifold has variable plenums. It has variable plenum volume, which is really freaking cool. All right, so there's a Corvette motor. There's butterfly valves in the intake plenum. So it works like a dual plane, and then those valves open, and then at high RPMs, it works like a single plane. It's really freaking cool stuff. That's really freaking cool. I don't think that's the right picture. But yeah, that's a really awesome piece of engineering by Chevy. And I don't say that lightly, you know what I'm saying? Yeah, it's really neat. There's butterfly valves in the intake manifold. I saw a picture of it somewhere. I don't know where it is. Yeah? No. Yeah, it's cool stuff because once again, it's a reservoir, and at higher RPMs, the air is the engine's moving more air. So you need a bigger reservoir for more air. In the past, it was just kind of a fixed thing. But Chevy's coming out with variable exhaust plenums, which is really cool. It makes it so the motor can perform really well on the low and high end, which is one of the tricks that they use to squeeze more performance out of engines. You ever notice that like nowadays a freaking Toyota Camry is faster than a Corvette from 20 years ago? Like way faster. That's why like they get every motor to perform better, because they do cool stuff like that. So on weird news, SpaceX is bulk hiring Starship engineers in Austin, Texas. Are they moving the HQ there? I don't know, maybe. Yeah, JuiceBot, exactly, right? Yeah, if you've been driving cars for a long time, you know that cars are not very... It's only very recently that cars, like every car can go fast, you know? When I was growing up, man, if you had 300 horsepower, you were unbeatable. Unbeatable at the track. 300 horsepower, you know, 13, 14 second car, you were unbeatable. No one could touch you. Like, that was fast. Nowadays, like, that's not fast at all. That's snail. A freaking Honda Accord can go that fast. Yeah, like, stock Honda Accord can go that fast, you know? Why is there a 400 horsepower Ford Explorer? I don't know. Now, don't get me wrong. Not everybody does a variable intake plenum, but yeah, there are a bunch of cool ways to get that done. Like, Bill, I like the 4AGE, the Toyota engine from the Driftu, from the Hachiroku, the Driftu. Like, oh, nani, the Drifto. Like, the 4AGE has like it doesn't have variable intake plenums, but it has something, there's something to do with the intake to change the plenum geometry. I forget what they were doing. They did something, Toyota did something weird with the intakes. Yeah, Glowfly, it's really neat. But yeah, RB, that thing is missing a lot of parts because it was scanned. They can't get the scanner in the intake plenum. Ford has done intake runner valves in some cars. Yeah, Bill was saying that the SHO did that. But yeah, that's cool stuff, man. But yeah, I didn't do very well with the NASA questions. I don't know. Should I do that more often? I don't know if I should do that every time. I should do that when I'm confident in myself and the answers. And in this case, I got Dunning-Krugered pretty hard. Yeah, see? That's what I mean. I'm not at the peak of Mount Stupid, but I ain't anywhere near the end of that curve. EJ's dumb. Thanks, man. Thanks. Feels terrible, man. 4AG had lots of valves. Yeah, look at that. 5 valve. That's right. That's right. It's a 20 valve. Aston is crying. What's this? Wow. Okay. All right, dudes. Well, that was the SLS press conference. Let's see, what time is it? It's got 7 o'clock, so we got some time until racing here. What else do we have? Oh, okay. This is a quick side note for space news here. Let's check this out. Tony Bella on Twitter, B-E-L-A is the guy's last name. He does infographics. Look at this one. He did an infographic on the 50th anniversary for Apollo 16. Yep, Mattingly, John Young, Charlie Duke. Hell yeah. NASCAR is supposed to make a huge announcement tomorrow. The rumor is that North Wilkesboro is coming back. I can dream. Dude, look at that. That goes through all phases of the program. That's really, really cool. Oh, that's so legit, dude. Yep. Yeah, Death Cartel landing site, yep. That's cool, man. Look at that. Dude, you know, shameless shout out for the Saturn V second stage. A balloon tank 10-meter diameter stage with 5 J2s in it. Yeah, no, I just wanted to call that to your attention. Yep. Link? Sure. Careful you don't kiss a death his sight, boys, okay? Think about that for a second. That's a 10-meter balloon. Well, actually, you know what? It's not a balloon tank. I stand corrected. That's not right. It's not a balloon tank. It's a common bulkhead. So that's an aluminum tank, aluminum with stringers, balloon. Not a balloon tank, EJ. An aluminum with stringer, 10-meter diameter tank. That's hardcore, dude. 5 J2s. So each one of those J2s makes about 1,000 kilonewtons of thrust, which is, man, that is a beastly upper stage. Yeah, Zonic, right? That's a really cool infographic from Tony. That's awesome. I won't go through the whole thing. You guys should go check it out. You know, if you want to see more, I linked it up in chat. Okay, check this out. This is coming from BWX Technologies. They tweeted this today. Not sure if it's any particular thing, but I mean, I figure you guys would want to see it anyway. Here's the cutaway on the intake of the C8. Oh, that's from EE. Yeah, Engineering Explained. Yeah, that's where I learned about that. Yeah, from EE, because Jason is really smart and way smarter than I am. But yeah, you guys click on RB's link, you can see the butterfly valves for variable plenum geometry. And RB, do you see how there's trumpets? There's trumpet intakes inside of the plenum. It's pretty cool. Trumpet intakes. It's got ITBs, but the ITBs are inside of the intake manifold. It's really freaking cool, man. Yeah, here. This is coming from EE. I'll get to this in a second. Let's see. Yeah, look. Look at that. There's no intake runner. It's a... Oh, man. That is next level stuff, dude. So, it's a dual plane intake manifold. The air comes in here, and then there's a gap right here, and it splits. It goes to the left and to the right. And then this is the entire plenum, this reservoir of air, right? And when that pressurizes... And, you know, RB, it's interesting to note that there's 3 butterfly valves. I wonder if these are independently actuated. So, like, can it open 1, 2, and 3? That would give you better... Huh. No, you wouldn't want to do that now that I'm thinking about it, because it's not going to change the volume if you open one over the other. So all 3 of them are going to open. Interesting. It's not going to change the volume too much, but yeah. So basically, when the motor gets high enough revving, these open, and it makes one big intake plenum, which is really cool. And then the air gets sucked through these trumpets, and then trumpets. That's cool. Really neat. All right, so this is coming from NASA. This was a press release from a couple of days ago. NASA's new material built to withstand extreme conditions. NASA innovators recently developed a new metal alloy using a 3D printing process that dramatically improves the strength and durability of the components and parts used in aviation and space exploration, resulting in better and longer-lasting performance. NASA's alloy, GRX-810. Are you Ladies Man 217? An oxide dispersion strengthened alloy. Yep. I understood some of those words. Can endure temperatures over 2,000 Fahrenheit, is more malleable, and can survive more than 1,000 times longer than existing state-of-the-art alloys. These new alloys can be used to build aerospace parts for high-temperature applications, like those inside aircraft and rocket engines. Because ODS alloys can withstand harsher conditions before reaching their breaking point, the nanoscale oxide particles convey the incredible performance benefits of this alloy. Okay. All right. Yeah. I know what that means. It's challenging and expensive to produce ODS alloys for these extreme environments. To develop the NASA alloy GRX-810, agency researchers used computational models to determine the alloy's composition. The team leveraged 3D printing to uniformly disperse nanoscale oxides through the alloy, which provides improved high-temperature properties and durable performance. This manufacturing process is more efficient, cost-effective, and cleaner than conventional manufacturing methods. Wow. Here, I'll link this article. That's cool, man. Let's build some rocket motors out of that, shall we? I mean, look at this thing. What? Huh. That's 3D printed, man. Yeah, Lego, right? Interesting. Yeah, Bill, I wonder if this is easier to make than an Inco alloy. It says it holds up better than Inco, which is kind of crazy. Sweet. That's really cool. I'm going to read more about that later. Here, check this out. Check this next thing out. BWXT, I was talking about this a second ago. I should probably give them a follow. Is working with NASA in support of the agency's NTP project, Nuclear Thermal Propulsion. We're responsible for providing design content for a reactor in hopes of powering a future crew mission to Mars. Boop. Hey. Huh? That actually looks very similar to Nerva. I mean, it is a Nerva engine. It's a nuclear thermal, but that looks similar in design. The nerve of them posting this. Wow. That's really cool. It's got an extendable nozzle too. Extendable nozzle like an RL-10B. Hey, they stole the engine design from KSP-2. Gimbalable. 1 turbo pump. Elon did a TED Talk yesterday. That has nothing to do with space is the end of that sentence. As cool as this is, what's mind-boggling is that somebody actually envisioned this in the brain, in the mind. It's a wonder of evolution. Brian, you want me to really blow your mind? Somebody envisioned this in their brain and built it 50 years ago. Nerva engines are nothing new. They were gonna take Saturn V's third stage and make it a nuclear engine. So the Saturn V third stage could be used to take cargo to and from the moon, not just to. Yeah, they were gonna do that. And then after that, the running plan when Apollo was canceled was to take 3 of those things, couple them together, and use that to make a nuclear transport vehicle, and it would end up looking something like it'd end up looking something like the Republic cruiser from Star Wars. Yeah. They were going to take 3 stages, right? 3 nuclear-powered S-4Bs, right? Couple them together, and then put HAV modules in front of that. And I think there was going to be a 3rd or 4th stage right here. They would use 3 to get to Mars. The vehicle would stage while it was doing its transfer burn, dump these, use a single nuclear in the center, and then when it got to Mars, right, use what's left over in this to circularize around Mars, and then use 1 stage to get the transfer vehicle home. Yeah, that's what they were going to do. They were gonna cluster nuclear engines together or cluster nuclear stages together to make a Mars transfer vehicle. That's what Apollo wanted to do. It's part of the reason why they needed Nerva, not Nerva. They had Nerva. That's part of the reason why they needed Nova. To be able to build something like that in space would have been crazy, because what they wanted to do is put like a Skylab on the front of that. Skylab wasn't just a one-off thing. Skylab was a prototype for the HAV module for transfer vehicles for the Apollo program to go beyond Earth and the moon. Yeah. The Skylab 1 mission was just a prototype. It was a prototype HAV module, and that also was derived from Saturn V's third stage. They were going to take that, put a nuclear stage behind that, and then put 3 nuclear stages behind that in stage, which is really freaking cool. I forget if the test ban or Sol 1 killed the Nerva the first time. Nuclear testing ban, partial nuclear testing ban, stuck a fork in it, and then the Apollo program canceling basically old Yellered that program. What about the exhaust? Won't that be radioactive toxic? It'll be radioactive, Jebediah, in space, which is also radioactive. They wouldn't be firing it down here. It's an upper stage. It's designed to work on orbit. There's a lot of radiation up there, so I wouldn't. It's a drop in the bucket. So now, in terms of like radiation between you and like the people inside up at the front, like the people that are on board, as long as they stay far away from the engines, you're fine. Yeah. What you wouldn't, believe it or not, in space, what you would not want to do is put like a lead shield or something, because the lead shield, while absorbing the radiation from the engine, will also absorb the radiation from the sun and from everything else, and you'll actually make your ship a radiation magnet. With spacecraft, and this is one of the reasons they figured this out during the Apollo program. This is one of the reasons, how we know is because of the Apollo program. Making your spacecraft bouncing the radiation is what you want. You want something that doesn't absorb it. Absorbing it would be bad. My joke is that putting lead on a spacecraft would be like making a boat hull out of a sponge. Yeah, it's my sailboat. It's made out of sponge, but it's boat shaped. Let's put it in the water. No, let's not. No, that's not a good idea at all, right? So you don't really want any lead lining or anything like that. You want something that's not going to absorb radiation but reflect it, and that's what the Nerva engine does. It has to do with neutron flux and moderation and all and a lot of nuclear physics. But yeah, will it be toxic? Yeah, if you fired one of these things down here, I mean, it's probably not the best thing, but it's not as bad as one might think. But most of the time it would have been used up in space. However, with that being said, if you really want to know how that engine works, is basically they have a nuclear reactor. It's a nuclear reactor. It's basically a reactor, but it's a reactor that's inside of a rocket's combustion chamber. And I know that sounds ridiculous, but nuclear engines don't combust anything. They just heat stuff up, just like a power plant would, right? So a nuclear power plant would have a coolant loop. And you know what happens when you shut those off. They figured that one out in 1986, why you shouldn't do that. Also graphite tips, but whatever, that's another story. So basically nuclear reactors generate a lot of heat. And how the Nerva engine works, right? How that Nerva engine works is they flow liquid hydrogen over it, and the liquid hydrogen cools the reactor so it doesn't melt, and it superheats the hydrogen, and they shove that out the back. That's its propulsion system. So it's kind of like a rocket, but it doesn't really combust anything. It just heats up hydrogen. That's it. But hydrogen really likes taking heat. It's really good at it. I mean, helium is too, but hydrogen and helium are kind of, I'm going to say distant cousins, but that's not really the right way to put it. Chemists just went, no. But yeah, you can't use helium. I mean, you could use helium here if you really wanted to, but I think hydrogen is better at absorbing heat. Helium is good at it too, but it's inert, so I mean, you generally wouldn't make a coolant loop out of hydrogen because hydrogen makes stuff blow up really nice. So they shoot hydrogen through a nuclear reactor and force it out the back. So the thing about it is that hydrogen, that irradiated hydrogen that comes out the back, has a really short half-life, believe it or not. What's half-life? Half-life, all radioactive materials are decaying. They decay. And the decay comes from splitting, the natural phenomenon of atoms splitting. And that's neutrons get shot out from radioactive atoms, and they eventually shoot out enough neutrons that they change state. They become something else. Most of the time it's just a different isotope of the same element, right? So what they can do, what they do, like the amount of time that different isotopes decay, right, is called the half-life. Like, how long does it take to basically fizzle out? The radioactive hydrogen or irradiated hydrogen that comes out of a nuclear engine, it has a really short half-life, so it's radioactive when it's coming out of the nozzle, but by the time it's like at the, like a couple seconds after it shoots out, it fizzles out. So believe it or not, the Nerva engines, actually, you could have a Nerva stage that works in the atmosphere, but they don't really make enough thrust because they're not really combusting anything. It just heats stuff up. So it's a really good upper stage engine. Nerva engines also are heavy because nuclear reactors are not exactly light, because it has nuclear material in it. Nuclear material is extremely dense. Like uranium, very dense. Plutonium, even more. Actually, I don't know that for sure, but you get the idea. So the shorter the half-life, the hotter it is. Yeah, exactly. So actually, it's not too bad. It's not as bad as you might think. But honestly, just like anything that has to do with anything nuclear nowadays, that's, not unregulated fission reaction. Anything that's not a nuclear bomb, people hear nuclear, they think bomb, they think it's going to explode. No, that's not how that works at all. Yeah, that's actually really safe. And they tested these down here in the 60s, out in the desert. They tested them out at Edwards Air Force Base. if I'm remembering that right. They tested these things. They're pretty damn safe, actually. Yeah, they're pretty damn safe. So what? It melts in space. It like say it did melt down. Okay, so what? I mean, the worst problem that you have at that point is your engine just melted. No, like not fallout. Space is already full of radiation. Now, granted, space is full of different types of radiation than what this thing would be giving off. But I mean, I'm about to say radiation is radiation, but that's not entirely true. There's alpha, beta, gamma types of radiation. It's all over the place. But yeah, it's a drop in the bucket at the end of the day. Would these engines have the ability to melt down? They could, if you don't use it right. But the problem, like, one of these things malfunctioning, you have about the same probability of, like, actually, like, honestly, a Raptor engine is way more complicated than this, believe it or not, dudes. A Raptor engine has way more moving parts. It's as likely to screw up as, like, having any other engine failure out there. That, honestly, like, it's not as bad as people might think. People just hear nuclear and go, you know, just like everything else, right? Crazy thought, if you need oxidizer for the turbo pump, make the turbo pump oxidizer rich and inject the exhaust as an afterburner. I mean, yeah, you could, but the name of the game necessarily isn't thrust with this, it's efficiency. Nuclear engines in the 60s, the Nerva that they made in the 60s, made 800 seconds specific impulse. 800. Hey, Meeps, what's going on? EJ, I don't expect you to do it right now, but I hit you up with a link to a video I made about NS-19 training and stuff. Heck yeah, Meeps. Okay, Meeps, I have a question. Was that nitrogenated Pepsi with milk and Oreos? Was that actually good, or were you just pulling our legs? Because I saw that and I'm like, what? Was that actually good or not? I couldn't tell if you were kidding. I'm like, wait a minute. What is he doing? What are you doing? Why would you do that? That's Pepsi. That's cool, man. I'll check it out, dude. I'll check it out. Meeps, show them. Just show them. Hey, Snake, what's going on? Crazy thought of you. Yeah, okay, I already went through that. I already answered that. Yeah, it could work, but kind of superfluous, dude. That's kind of a best part is no part kind of thing, because you don't need thrust. Like, thrust isn't the name of the game. That would be nice. But yeah, we went on a deep dive once, and I had a nuclear engineer here talking to me through it, and I think if I'm remembering right, and keep in mind this was a little while ago. This is like a year or two ago. It was maybe in 2020, so it might as well have been 10 years ago. Am I right? I think we figured out that you could do that. You could do a staged combustion nuclear engine, like. It would kind of work similar to an RL-10. Yeah, it would kind of work similar to an RL-10. You basically you'd use the nuclear reactor to preheat your liquid fuel, and then you could use the heat from said nuclear reactor to drive the turbo pump, and you could use the oxidizer to cool, or you could cool with hydrogen, which would probably be better, and then use that as your staging, and then have the exhaust of the Nerva going into some type of expander cycle, like an RL-10. It's possible, but that would be super freaking complicated. That's like, let's get Nerva working first, is what I was told. Like, how about we figure out Nerva first before we go and do something like that? But it could be done, sure. I'm not sure what the application would be, because once again, you're using upper stage. You're using nuclear engines as an upper stage. It's already heavy because nuclear reactors are not light, right? So you're adding, I'm not sure, I think the conclusion that we came to is I'm not 100% sure if it's worth it doing something like that. Is it worth adding the extra dry mass for a little more thrust? Just got back from a KSC networking event. Jacobs has some pretty dope goodies. Yeah, of course. Oh. Bembo, that's nice. Oh dear. You need materials that could survive middle of the sun kind of temperatures. I mean, Raptor can do that. Tessa, you can have something hot flowing through a metal that it could theoretically melt as long as you do it fast. So the heat doesn't have time to melt it. It's why jet engine stators, like jet stators and turbine blades, don't melt. I mean, they do, but you get the idea. Did you check this out? LC-36 planes got updated. But yeah, anyway, BWXT is... I know, BWX Technologies. It's BWXT, like Rooster Teeth, but... they are working on space nuclear propulsion, which is really freaking cool. Yeah, that's awesome. This nuclear propulsion, guys, you want the sci-fi... Hey, Dragon and Ian. 13 months. Dragon had a 30-monther. Way more mass. Yeah, Rocket Guy, I'm pretty sure that a staged combustion cycle Nerva is, yeah, it's not, it's a little bit thrust increase for a lot more mass. It's too much of a diminishing return. It could be done. It could be done. And if you needed an application for a high thrust Nerva, it's possible. Yeah, sure, why not? But once again, it doesn't really make a lot of sense. You're good enough with what the nuclear reactor can do, just accelerating the hydrogen out the back. Hey, Jado, 8 months. Yeah, God, time-sensitive maneuvers, but once again, you're lugging all that extra mass around. Why not just have another Nerva engine? Why not just use 2, right? That is a much better thrust for mass, right? Atomos 2. Are there nuclear designs without oxidizer? Jebediah, that does not have any oxidizer. That uses hydrogen, and that's it. All a nuclear thermal engine does is heat up hydrogen. That's it. So the hydrogen goes through the turbo. It goes through the inlet right here. Okay? Goes into the turbo pump. The turbo pump is driven by a tap-off, so some of the hydrogen goes to cool, like the nozzle or the reactor on the outside, right? Some of that hydrogen... We know from SLS, from what we learned about SLS today, right? A hydrogen hits that hot nuclear reactor, it turns to gas, that gas drives the turbine, and then the turbine outlet goes right back into the engine, but most of the propellant goes in through an injector mechanism, and they flow, no, it's not really an injector, it's just an open valve, and they flow it through the reactor and out. Yeah, there's no oxidizer in this design. All it does is it uses hydrogen's ability to turn to gas when absorbing heat to drive a turbo pump to pump fuel into the engine and just flow hydrogen over a nuclear reactor. It's not so much like combusting anything, but literally just keeping the nuclear reactor cold. That's how much heat nukes can make. They're very, 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 very good at generating a lot of heat really easily. So they do that from half-life, like what I was telling you about. But that's what nuclear materials can do. It has insane what's called energy density. So, say, okay, this can is 355 milliliters. Say I had 355 milliliters of gasoline in here. That could get you, I don't know, 5, 10, 15, 20 miles in a car, something like that. Or like what, like 40, 50 kilometers, right? If this was a lump of coal, provided I could put that in a car and make it work, how far would it get you? Not very far. Coal is probably worse than gasoline. If this was diesel, it'd probably get you a little bit more. So like if it was 355 kilograms of coal, and you burned it and you could make heat and use that as propulsion, it wouldn't get you very far. Gasoline would get you a little bit further than that. If this was 355 kilograms of uranium, you could drive clear across the country, provided you had some type of nuclear propulsion for your car. Probably not a good thing on the roads, but that's what I'm talking about. A little bit of this chroma can, 355 kilograms of coal can make a nice campfire. Okay, for heat. 355 milliliters. 355 milliliters of like gasoline could power like an RV for a little while, right? 355 kilograms, which is the same as 355 milliliters, right? Not the same, but you get the idea because metric do be like that. If this was uranium, you could power a small city. That's the energy density difference. How much energy is in a certain volume? Nuclear has insane energy density. It is way better than anything we have by a long shot. Yeah, not grams. Yeah, sure. Yeah, it's grams. It's not kilograms, excuse me. Sorry, metric. Metric isn't my first language. See what I did there? Yeah, so this could, like, this much uranium, if you had enough to, like, fill up the can with uranium, or, like, uranium ore, you could power a small city. Oh, yeah, easily. Like, a city with, like, 100,000 people in it. Yeah, no problem. And you could do it for, like, a good couple of weeks. That's the energy density of nuclear. And when you use that in the application of a rocket engine, first of all, the nuclear engine can power your spacecraft. You could take some of the tap-off heat from that nuclear engine and use it to drive literally an alternator and generate power for the spacecraft, which is great for something if you're far away from the sun. Solar panels don't work too well out in Pluto, guys. Or even at Jupiter. They really don't work very well. Why? You're literally further away from the sun. Yeah. They don't work as well. So not only can a nuclear engine power a ship in deep space, but it is probably twofold efficient. It's like twice as efficient as what we currently have, like 200% increase in efficiency, or 100% increase in efficiency. So if you had like this much hydrogen in a tank, right, and this much oxygen in a tank, you could get, I don't know, you could accelerate like 20 meters a second. If you had the same thing with nuclear, you could accelerate 40 meters a second. It's literally double because the specific impulse is double. Now, don't get me wrong, rocket science is way more complicated than that. It's not just this quantity will get you this far. It depends on what the mass of your engine is. All right, what propellants are you using? Hydrogen. You're using hydrogen. What are you moving? Where are you going? What are you going to? There's a lot more things. There's a lot more questions to answer. Literally thousands of questions to answer, and that's why just to turn everything back together, just dial it all back in. That's why people say space is hard, because there's a lot of questions to answer. What are you trying to do? Where are you going to go with this nuclear engine? Can the turbo exhaust be used for power generation? Absolutely, Lego. Sure, of course. Yeah. In fact, that's what I would do. You have a nuclear reactor on board your spacecraft. Don't just use it for propulsion. Use it to generate electricity. That coupled with some good batteries, you don't need solar panels on a spacecraft. Now, don't get me wrong. I'd probably still put a solar panel on the spacecraft just in case, As a redundant system, solar panel's not that much mass. Like just a single fixed one or something. Just in case. But yeah, it's a good idea, right? Especially if the vehicle is taking a long coast, Mining that much uranium is difficult, is it not? No. I mean, no more difficult than mining anything else, except you've got to be careful it doesn't kill you, right? Like, logarithmic scale. Yeah, relevant XKCD. Fuel energy density in megajoules per kilogram. So 1 kilogram of sugar can deliver 19 megajoules. 1 kilogram of coal can deliver 24 megajoules. Fat or lipids can deliver 39 megajoules. Yeah, that's what we use for energy. Fat. I know, it's funny. Gasoline, so this would be, 1 kilogram would be 1 liter, right? Just kiloliter? No, that can't be right. 46 megajoules for gasoline. This is kind of the norm right now. See that? 1 kilogram of uranium can deliver 76 million megajoules of energy. This is what I'm talking about. Oh yeah, Tessa, that's right. Yep. Why wouldn't you want to use heavier gases? Well, okay. But my nuclear bad. Yeah, I know, right? Lego, why wouldn't you want to use heavier gases? Well, one, higher mass, more mass to move, right? That's bad for delta V, even if it is wet mass. Like, even if it is fuel. It's still a lot of fuel to move, right? And nuclear engines already suffer from low thrust output. It's low thrust, but it's super efficient. Now, the other thing is, so Lego, you know how, like, okay, what are wires made out of? What are wires made out of? Like the wires in your computer, what are they made out of? Not the outside. What is the metal? What metal are they using? It's copper, right? They're using copper. Why? Copper is good at conducting electricity, right? Hydrogen is really good at conducting heat. What is electricity? Electricity is energy. Heat is also energy, right? It's a different form of energy. Certain gases can absorb that energy better than other gases. That's why, for instance, like helium is used a lot for cooling, because helium is really good at absorbing heat. It's really good. So the thrust game wouldn't be worth it. Honestly, hydrogen is probably the best one, Lego. Yeah, you wouldn't, I mean, you could use helium, I suppose, but helium is higher mass than hydrogen is. Trout just crushed a 472-foot home run. That's a long way, Bandit. Damn. Copper, ironically, is also good at conducting heat. Yeah, bingo. So is, yeah, brass is good at conducting heat. Aluminum is really good at conducting heat. But some metals are good at conducting heat. They're good at taking heat in. But some metals are bad at spreading heat around. That's called heat flux. Yeah, you know, some of them, some metals keep heat like concentrated in one area. It can absorb a lot of heat, and that has to, that comes with like molecular density of like whatever you're heating, like steel. Like what is steel made of? It's carbon and iron, right? Like if the density is higher, you can absorb more heat, but also like the heat, there's heat transfer, like so heat flux, right? So aluminum, if you like have one source of heat, like on a block of aluminum, the whole block will heat up. If you do the same thing with steel, right, it'll only be concentrated in one area. Yeah, weird, right? That's why crucibles that move around like molten aluminum, they're made out of steel, right? Because it's good at absorbing the heat, but it doesn't, the whole thing doesn't, it's good at conducting the heat, but it doesn't flux it around. That's why you can, like in a steel mill, you can have a steel crucible in a steel mill and have molten steel and pour it in there, and it's not really that big of a deal. Sometimes crucibles are ceramic too, because rocks are really, really, really good at not fluxing heat anywhere. Rocks are really good at it. I'll give you an example. One time, NASA had an idea of literally taping 30,000 rocks to a spacecraft and trying to bring it through re-entry. Yeah, you know what it is. Those tiles are rocks. It's silicate based. They're rocks. They're very, very light porous rocks, but they're rocks. Yep. That's what those tiles are. They're rocks. Yep. These tiles are really, really good at absorbing heat, and they suck at fluxing heat, which is why the shuttle could make it through. They can absorb heat like champions, but that heat stays concentrated on one side. It's really freaking cool stuff. How do we get the shuttle to re-enter? Pigs! Apples! Very small rocks! Exactly! If the shuttle weighs more than a duck, is it a good re-entry vehicle? Yeah, that worked, didn't it? More like air. It's very, very porous, but it's rocks. Yeah, they glued a bunch of rocks to the bottom of the space shuttle. That's the plain Jane way of saying it. I was thinking of the wrong rocks. Oh, it's looking good, Sawyer. It's coming along. No bumper life. Jeez. Will nuclear energy ever be used in human spaceflight? KSP, they're working on it literally right now. That's what sparked this conversation. BWX Technologies is working on a nuclear engine right now for NASA that is an awarded contract. Yeah, yes, absolutely. If Artemis goes the way that I think it's going to go, yeah, we should see one of those tacked onto the bottom of an EUS with no oxidizer tank. At least that would be my guess. That's how I would do it. If asteroids can use it, so can we. That's right. They put rocks in space, like they did surgery on a grape. Yep. So some idiot cancels it because they have a dented head. Yeah, Savvy, that's why I'm here on the front lines every day doing what I do. Anytime some bonehead comes along that's at the peak of a Dunning-Kruger curve, says that we can do it better if we did this, they deserve to be slapped and shunned. Every time someone has said that, we have ended up with net less capability. Oh, Apollo isn't worth it. The shuttle can do it better. Let's just surrender that capability because this will be better down the road. Lost the ability to go to the moon. Oh, you know, the shuttle is old. You know, why don't we... let's replace it with the Constellation program. You know, it's the same capability. It's shuttle-derived. It should work. Okay, that's actually not a bad idea. Oh, no, never mind. Let's not do that. Commercial can do it better. Literally lost the ability to get into orbit. Your space flight organization lost the ability to go into orbit for 10 years. See what I'm talking about? Yeah. Every time someone comes along and says that, they're wrong. Historically. Yeah. And no. So send them to host the Oscars. Indeed. Yes. When are you going to replace those rocks with aerogel? When it's the right thing for the application, Hunster. I don't know. Flux is heat. Okay, Novus, yeah. See, I don't get this right all the time. Let me see. Flux is heat going through a per area of the material. Specific heat is how much heat it'll take to raise the temperature of a material to a degree. Thermal conductivity coefficient is how easily the material spreads that heat through itself. You mixed up some of those terms. I did. I didn't get it right. So flux is heat into object. Specific heat is how much heat is in it, and thermal conductivity coefficient is how easily the material spreads the heat. That's the one. So flux is into the material. Okay? I'm just saying this so I can remember it. Flux is into the material, and then thermal conductivity coefficient is how much it can absorb. Got it. Yeah, I said that wrong. I said that flux is how much it can absorb. That's not right. Yeah, I got you. Thank you. Like, don't get me wrong, man. Still self-taught. And I didn't really expect to talk about thermal conductivity coefficient today, but that's not your problem. That's mine. So thank you for helping. And I sincerely mean that. Thank you. Should never stop learning, dudes. I don't get it right all the time, but I clarify and we move on. Move on. Okay, so let's go over and see what's going on with Blue Origin. So Harry Stranger on Twitter, yes, that's the guy's name. Shut up. It's a pretty awesome name. Posted this. Let's see what we got. Flux is specifically heat through some area of metal. Heat transfer is the term for heat going into something. Transfer. It can be hard to remember. Well, Novus, I should probably, make it a thing to not get that wrong. But yeah, got you. Let's see. Blue Origin have submitted updated plans for Launch Complex 36. The updates include a footprint expansion of the refurbishment facility and the addition of 5 camera tower foundations and a GS1 test area. Okay. Interesting. All right, let's see. Over here. Yeah, okay. What is 8? LC-11 walk tents? Walk tents? Oh, okay. Interesting. It's cool that they kept the blockhouse from Slick 36. That's my favorite. Walk tents. Is that frying your brain? A little bit. So 2. A lot of 2. Cable tray. 3 is the LC-11 guard booth. That should be over here. Okay. It's funny that they're still calling it LC-11 and LC-36. Blue Origin basically took 3 existing pads and made it one. This is down at the Cape now. There was one launch pad over here, and they launched Complex 11, which was, the launch pad was like right where the 50 is. And then there's Slick 36A and B. Slick 36A and B were a modified Atlas pad designed to have the Centaur upper stage on top. If I'm remembering, LC-11 was also an Atlas pad, but it was Atlas Agena, so it needed different servicing equipment. And at the time, they didn't really think of just adding more service equipment over here. They made a new complex for Atlas Centaur. So 36A was right here, and then they built another pad next to it, 36B. And 36A and B and LC-11 are now all one pad, and they just called it Complex 36. This is in Florida. I can show you exactly where this is, fellas. Do you think the first flight of New Glenn will be a success? Yeah, of course. They can test their engines on Vulcan, Caspi. Yeah, I'd say that it'll be pretty damn good. And that's just conduction stuff. Just wait for radiation heat transfer. Ugh. So, yeah, we're looking at right here at the Cape. There's 11, 36A, and 36B. That's what it looked like before Blue Origin got a hold of it, and this is what it looks like now. Little bit different, but they kept the 36A control room, which is cool. I don't know what they're probably not going to use it as launch control. That's way too close to the pad for such a big rocket. Wok stir fry? Ah, damn it! Now I'm hungry. Chat, why? He's always hungry. I'm just looking around. These pictures got updated the other day, and yes, those are work tents, not walk tents. They're freaking Elon tents, dude. Whatever. It's, you know, it's got a bunch of connexes, and they put a tent on top of the connex to make a work area, which is interesting. Just got pizza. It always wins. You piece of poo-poo. Why you do this to me, Clayton? Interesting. That's the Jarvis area from what Ian said earlier. Yeah. And there's the test article right there. Blue Origin, after, I think it was after SN15 landed or something last year. Was that last year? Almost a year ago. Or even, I don't know when that was. I'll just be honest with you. They rolled this thing out. They rolled a stainless steel fuel tank out here. And there are rumors going around. And once again, it's just rumors, so I don't know. There are rumors going around that that's a reusable upper stage for New Glenn, so that would be really cool if that's true. Okay. That's cool. Alright, let's tune into some Starship videos, shall we? Finish off some space news with some Starship fun from our friends over at NASA Spaceflight. I said I would do an update today, so let's get to it. Looks like we got 3 videos to check out. So once again, this footage is coming from our buddies over at NASA Spaceflight. Please make sure you go over there and sub to their YouTube channel. Subbing to them and supporting them over here helps me keep doing what I'm doing here. Basically, they allow me to put my terrible commentary over it. You've heard me make this joke before, huh? Alright, cool. Sub to NASA Spaceflight. You won't be disappointed because you get to see daily updates about what SpaceX is doing with Starship. It's pretty damn cool. Yeah, Thomas, that's neat. All right. All right, Creeper, we'll check it in a moment. Okay, so SpaceX is still loading commodities into the tank farm. I can only assume that this is in preparation for an orbital test, but I'm not sure. That's the pad in the tower. SpaceX is, of course, still waiting on a programmatic environmental assessment from the FAA. That is, I think it's now scheduled to come out on the 28th of this month. So in about 13 days, or about 2 weeks. This is the update from what's going on down in Tejas, JWA. They're working on Booster 5. Interesting. Whenever it's the orbital flight is pending the results of the PEA, KSP. Yeah, I know. A little bit annoying, huh? But it's alright. Burb. I had this question for the longest time. Do U.S. schools use imperial or metrics for physics in school? You know what, Swishio? I don't know. Somebody that's in school right now would probably be privy to answer that, because I didn't really pay attention. I didn't really pay attention in school, and B, it was 15 years ago, so I have no idea. Did you light off rockets as a kid? Of course, JWA. For engineering, unfortunately, both. Swishio, how we do things is kind of like the UK, where like we really can't decide feet, miles, you know, meters, kilometers. Like it's like you get a lot of just different measuring systems over here. For most engineering, like I guarantee you, SpaceX is using metric. I guarantee you that that's what's going on. So. Yeah, it's kind of, well, like highways are like miles and feet and stuff. Like, I don't know, man. This is why, dude. Maybe this is the reason why I freaking just don't really care what measuring system you use, as long as you understand what measuring system you use. And I know that pisses off everybody that likes metric. I don't really care what you think. Sorry. I'm not the one that has to deal with multiple freaking units of measurement, okay? Or you're not the one that has to deal with multiple units of measurement. I have to, so I do what works, okay? There's all kinds of stuff. Whatever, it's fine. I don't make a big deal out of it. Kilofeet is the one true unit of measurement. Why, Boo? Why would you standardize yourself? Why would you do that? There's some, dude, sometimes measuring systems are better suited for an application. Honestly, in terms of distance for like cars on the highway, I think miles is light years better. Just because it's good for measuring like longer distances. Yeah, screw me. I don't know. I know people are going to disagree with that, but yeah. I don't think you should constrict yourself to one unit of measurement, because you know what? You know why? Because I could say, oh, this pipe is 50 cal. If I say the diameter of the pipe is 50 caliber, what does that mean? What does that mean? Inner diameter or outer diameter? Outer diameter. What's 50 cal? It's a ½ inch, right? There's no ½ inch measurement. It's just a ½ inch. 500 thousandths of an inch, which is the exact same as 12.7 millimeters. It's the same thing. It's all the same thing. You guys told me exactly what I need to know. When you engineer, you find the best unit for application. And if you're doing some type of analysis and the outer diameter comes out to exactly a half inch, it's going to be easier to just say a half inch than it is 12.7 millimeters. But you got to make sure everybody also understands that. I constrict myself to one type of measuring system. That doesn't make any sense to me. And once again, I know people get confused every time I say this. People get confused. I'm not saying that metric isn't easier. It's way easier. Of course it is. Of course it is. Like, you'd be stupid to not say that. This isn't about the superior measuring system. It's just using whatever makes sense. And engineering is about application, even when it comes down to measuring systems. And you know what? All the metric people are like, no, that's wrong. It's not. It's right. That's correct. You use what makes the most sense in the application, and that's literally engineering in a nutshell. And I will concede that most of the time that's a metric unit of measurement. Like, most of the time. You'd be like, people don't understand. They understand, like, people think that I'm saying, like, oh, we should use feet and miles, right? Like, I understand I said it with, like, highways, but most of the world doesn't, right? Most of the world disagrees with me on that. I understand that. And I don't get up people's tail about it, you know? Like, I'm agreeing. Most of the time, metric is the right thing for the application, but... Yeah, there you go, Swishio. Moving that bulkhead around. That prototype bulkhead. See the different shape? Yeah, the Tupolev 4, Kentab. Yep, because they couldn't produce an Imperial. The Soviet tooling was for metric. Yeah, Tupolev 4. Look it up. It's a B-29 copy. It didn't work right. They didn't get any of the tolerances right because the tolerances were Imperial. So they made literally an exact copy of the plane within their means, and it sucked. It was a piece of junk. Huh. Just cutting up that bulkhead there. Huh. Never fails, Electro. Maybe they're cutting it out to X-ray it or something. Oh yeah, you gotta get all the freaking metal dust off of you. It's such a pain in the butt. Yeah, Bill. That would be my guess. They're probably taking it off to inspect the weld on that bulkhead. Yep, and they're gonna move it for scrapping. Okay. Yeah, there are varying levels of engineering, Kentab. That's what I'm trying to say. If you're going to build a house, you don't need to use millimeters. That makes no sense. That's a waste of time, right? It's a waste of time. Inches and feet make much more sense. It's a house. It doesn't need to be precision engineered to, like, aerospace tolerances, right? Oh, that's junk. Inches and feet are just fine. It'll work. It's very informal because it doesn't need to be formal. You know what? It doesn't need to be precise. And once again, fellas, I'll say this till I'm blue in the face. Metric is the right move for aerospace engineering, 100% of the time. Like, it's very rare that you'd use feet for something. Not even NASA does that, you know. But you don't need millimeters or thousandths of a freaking inch to build a house. Can those domes be able to detach in an emergency? That's the fuel tank, Stuart, or at least it's a piece of one. No, they wouldn't be able to detach from the vehicle. Can be changed to units, and I think that the inactive drives standardization of repetitive units. I guess if you want to engineer your house in metric, you could. I think that's jumping through way more hoops, but... Okay. I mean, boo-woo, standardizing our measuring systems all over the place sounds as ridiculous as standardizing language all over the place. But I don't know, man. That's how I look at it, dude. If you disagree, that's fine. That's cool. I get it. Metrics way easier, and it'd be nice if everybody spoke the same language, right? But that's, it's oftentimes it's more complicated than that. If we want to talk about a social component, right? It's way more complicated than that. Why doesn't everybody just speak English? Yeah, that doesn't sound... I mean, that'd be nice as an English speaker. It'd be nice, but that's not how it be, man. Yeah, right, Bill. Because it's right for the application signer. I'm just glad we don't have two different measurements for time. Dude, Novus, hold on real quick. Sometimes my brain gets that wrong. So, like, I'm like, somebody asked me, oh, that rocket is launching at 9 your time. What time is that for me? And I rack it in my head, and I'm like, what's the unit conversion for time zones? There is none. It's just an hour, like a couple hours. I'm like, wait, do they use hours? I don't know. Like, dude, sometimes my head does that. It's so stupid. It's so dumb. I'm like, wait, what time measuring system do they use? Everything else is different. Which one do they? Oh yeah, they use hours and seconds too. It's like everything else needs to be converted. Why wouldn't time be, right? Like that's how my stupid freaking head works, man. I've been trying to disconnect those neurons for a long time. It doesn't do it. My brain's just like, nah, they use a different time measuring system, don't they? They use metroseconds or kiloseconds or millihours or something. Like it's just my brain's so dumb sometimes, dude. Kiloseconds, damn it! They use sols. They would, a hexasecond? No! Alright, so there's SpaceX's payload base segment that looks like it has a Starlink dispenser on it. The Pez dispenser. Metroseconds? Oh, God! Parsecs? Oh, jeez. No, stone. Stone is the one. It's like, dude, bro. Like, look. Take it from somebody that gets judged for their measuring system. Stone? What are you doing? What are you? All right, I get it. Like, stone? The hell is that? No, I know what it is. Like, it's a weight measuring system. What's wrong with stone? It makes no sense, Cantab. We should use pounds instead. Because it makes more sense. See how dumb that sounds? What's wrong with slugs? $11.5 stone is 154 pounds. Nice. Don't get me started on drams. See? This is why I'm agnostic to measuring system. I don't care. I really don't care. I don't care. We could engineer it and kill a feed. I don't care. I'll use whatever. Whatever makes sense. Now, let's use pounds for currency. Yeah, I know, right? Imagine that. It's so weird, right? Wouldn't know nothing about that, LM. Buttload actually is. Everything shouldn't be it. Okay, all right. Final thing on measuring systems, guys. Let's get back to watching Starship stuff. My final thing is that, well, you know what? All measuring systems should be measured in SMB, standard banana, standard measurement banana, banana for scale. Yep. Banana SMB is the one true measuring system. Tori Bruno agrees. Exactly, Hank. You got it. Yeah, Swishio, typical European, wanting people from North America to be more like them. We are not the same. Okay? We're not the same. Typical. You tried that colonial thing over here, guys. It didn't work. Just saying. Didn't work. SMH my head. I'm kidding. I'm kidding. It's just a joke. Typical colonist, right, Boo? Come on. You know, Europeans ask me all the time, EJ, why are Americans so different? Why can't you just be more like us? Yeah, well, we tried that once. It didn't work. Okay? Duh. Ugh. Why do I have to think of everything? You're missing out on all the great things Britain can do for you. Hard pass. That's what I'm making a joke, man. I'm making a joke. It's a joke. All right, let's see what's going on. Looks like they're finishing up the roof of that wide bay, man. Can you imagine? It's like, how tall is the wide bay? 70 meter? See, metric. There it is again. Yep. That's a long way up. Yeah, that's like 230 feet. Yeah, 23-story building. Yeah, it's pretty tall. You know what the messed up part is? The wide bay is half the height of the VAB in Florida. That's half as big. Crazy, huh? Yeah, Kentab, bananas are the best one. Yeah, you're right. Yeah, no rads, no Renkins. Bananas. Radiation should be measured based off of how much radiation a banana gives off. Boom. How much radiation did the reactor give off when it melted down? 36 million bananas, sir. Oh my god. Oh my god. Banana equivalent dose. 32 million bed. Oh no! Oh my god! If you fell from the top of that building, it would take under 4 seconds to liquefy you. Good to know. That's bananas. Surely you can't be serious. I am serious. Don't call me bananas. It's pretty good. It showed 80,000 bananas. However, that was as high as the measuring device could read. 3.6 bananas? Not great. Not very tasteful. What? Sorry. That's fine, Hunster. 32 million bed! Oh no! Do you think they should make the mid-bay high enough to stack a full starship? Ultimator, there's really no reason to. I think their assembly building is the pad, so to speak. And I think that's done on purpose. What type of mushiness on the banana scale would look like after the fall? Liquefied banana. In your country, you measure by plantain. No, it's not the size, it's how you use your measuring system, right? Right? True. Damn it, I'm stupid sometimes, man. What's wrong with me? Ferd. Taco. Blue is hiring ISRU engineers. Sweet. Can't be serious. You're not a potato. Facts. What's that guy pulling in there? I can't really tell. I can tell that this is gate B3. Don't ask me how I know. That's the plan, Panta. Those solar panels there, or just strips of metal? I can't tell. It looks like they got wires coming out the bottom. Yeah, that's true, Knight. Yep. Yeah, they look like panels, that's right. What's that funny? Burp! It's the government inspecting NASA space flight's cameras with their drone. What is... I don't like this. Yeah, the bird did a pog check. The bird did a poggers. He inflates. What the hell? What? He turns into Big Chungus. Big Chungus. Oh, later, Holmes. Abracadabra. We get it, 7. You vape. Is it just me or the booster gets shinier? I think that's just the condensation on the outside blue. I don't know. It's a steam locomotive, is it not? I'm telling you, man, how a steam locomotive works and how a rocket works, not that far off. Both of them have a pressurized tank that actuates something. Well, some rocket engines have used pressure for actuation, but you get the idea. Dude, I still think that we could use rocket technology and rocket fabrication to make a modernized steam locomotive, and it would be really, really, really good. Yeah, that'd be really good. Boo-woo, I got a question. So if you heat up water, it turns to gas, it turns to steam. You can heat up nitrogen. Would nitrogen be called steaming as well? Like if you heated up nitrogen to get it to sublimate, like is that nitrogen steam? I don't think that's what that's called. That doesn't sound right. Yes? So why don't we use a cryogenic steam locomotive using nitrogen instead? Heat up nitrogen. Nitrogen's basically same than air, but a steam locomotive doesn't heat up the air, Snatcher. It heats up water. Because nitrogen's naturally a gas, so cryogenic steam locomotive. Oh gosh, the emissions would be mostly nitrogen. The nitrogen boils. Yeah, I know. Cryogenic steam locomotive. Why don't we just do that? Telling me we have a shortage of nitrogen? No. Friction stir welded aluminum boiler. It's designed to take pressure like a rocket engine is. Boo-woo, someone has to have thought of this. There's a look. Alright, that idea is too easy. It's low-hanging fruit. Somebody's thought of this, and I'm not exactly sure why it hasn't been done. Probably the complications associated with cryogenics, but cryogenic nitrogen is not that bad. We move liquid nitrogen around all over the place. But who knows? Anyway, I got a couple more videos for you guys here. Let's see. How much energy would it take to cool the amount of nitrogen needed to fuel this engine? I mean, yeah, I don't know. That's more engineering, not my sector. But yeah, is it called nitrogen steam? I mean, steam must be more efficient than nitrogen. Like, it has to be. That's probably why. It's probably better at turning into a gas than nitrogen is, right? But also, with cryogenic nitrogen, you could get a lot more in there, right? Because instead of H2O, you have N2. But yeah, Yeah, it makes more sense to use the liquid that's liquid at room temperature, doesn't it? Yeah, okay. High bay bar? That's cool, man. I'm guessing icing would be a major problem. Any more of a problem than a locomotive operating in the cold. There's no way you'd be able to freeze all that. I mean, the water's already frozen, but... Yeah, there's a reason why no one's done that. Boo-woo. Anytime I come up with an idea and it didn't take me long to come up with it, it's probably because it's been tried and somebody either killed themselves doing it or figured out that it was a really stupid thing to do. I'm gonna go with stupid thing to do. There's probably better applications there. But also, friction stir welded steam locomotive. Literally take a Falcon 9 core and use it as a boiler on a steam locomotive. It could work. It could work. Shh. Could work. There's the construction elevator. They're taking that thing apart. Or they took it apart. They're getting it out of there. Yeah, blue, right? Blue Origin is so fancy with Imperial and won't stream in metrics, but look closely. Yeah. I don't know, man. Whatever. Doesn't matter. It was tried in 1902. And? What's stopping us from using Hydrolox engines for power production? The amount of energy you need to isolate hydrogen 2020 is what stops us there. You need to insert, like, say to, like, in terms of like total energy consumed of getting your propellant, making your propellant, and then using it in an engineering application. Say you need 1 energies, well, I'll take 1 energy, please, to make it, right? Say this is with gasoline, for instance. 1 energy to make it, 1 energy to use it to drive your car, right? You would need 2 energies to make hydrogen, and then you would maybe get like, hydrogen's more efficient, so when you move your car around, you'd get 0.5 energies, right? So You have 2.5 energies consumed to do the same thing. That's why we don't have hydrogen cars. It doesn't make any sense. I'll take 1 banana, please. Yeah, see? Should use SMB. It's a good idea. The hydrogen fuel is hard to make. Yeah, it requires more energy to make the damn fuel. And what are you going to use to make the damn fuel? Hydrogen? No, you're going to use gasoline. Unless we use, unless a nuke could somehow make hydrogen, isolate hydrogen, you could, I mean, you could. The funny thing is that, let me pause it just for another second. The funny thing is that with enough energy, you can literally turn anything into anything else. With enough energy, you can, I mean, nuclear reactors literally turn lead into gold. Yeah, they can turn, like, lead, like alchemy, like anime, remember that? You could turn lead into gold with enough energy. With enough energy, you could turn like, aluminum into titanium with enough energy. The problem is that most of the time, it's easier to just go dig it out of the ground than it is to do that. Yeah, you can do that with enough energy. What is that? Huh. Ice cream fridge? Stage lighting enclosures, yeah. Sandblast station, pastry cases, looks like a clean room, sandblasting units. Yeah, I don't know. It's got a vent on one side, and then it's got vents with HEPA filters on both sides. See the blue? Those are HEPA filters. Whatever goes inside of this thing needs to be in a sterile environment. Some kind of clean room for the manufacturing of some kind of part, if I had to guess, because there's a lot of them. Look at that thing. Yeah, see? They're inlet fans right here. They suck in air from the back, and then they push air out these vents. That's creating a positive pressure. It's probably for manufacturing, if I had to, for putting something together. Twitter torture chambers. What is this, Thomas? We interrupt this Starship broadcast for a quick space meme. Mom, can we have the Saturn V mobile service structure at home? Can we have the Saturn V mobile service structure? No. We have Saturn V mobile service structure at home. Saturn V mobile service structure at home. I'll be honest, Thomas, if they had a Saturn V MSS, this green run would probably be, it would be a lot easier to fix things with the green run. Just saying. But does that constitute building that monstrosity? You know what, Thomas? Yes. Yes, it does. Yes, it does. Frick it. I don't care. Build it. It would be awesome. I want to see it just because the engineering would be amazing. Turns out if you IV drip budget into your really complicated lifter, you get that. Upstacking? So whatever this piece of equipment is, it needs different types of power. We have regular power right there and then industrial power right here. Yes, we have different outlets for that over here. I know, it's another thing we do differently. Shh. That's 110 on the right. Those two things over each other is 110 and the other one's 220, 240. That's 3 starships. That's pretty neat. You have different outlets too? Oh, well there's a relief. Just confused different with incorrect. You shut your filthy mouth, Foz. You shut your filthy mouth! You have that as well. Most countries do. Just you have bad voltage plugs. No, we do not. We do not. Our plugs are superior to yours. We freaking invented it. Shut up. I don't think... Yeah, we did. Ben Franklin, you're welcome. You're doing it wrong. I know, SD, right? Stop appropriating American culture. Jesus. It's ridiculous. This is I'm kidding. Just in case I'm please kidding. Those plugs are what got us to the moon. Damn right, sup. Could it be a display? I don't know. Stage lighting? Production, transportation, signage, and graphics, custom display scene. Let's go peek around on that site in a second here. I mean, Tesla was Serbian creeper, but it's fine. Don't tell them that. Those other two. Yeah, I don't see your plugs on a rocket ship. I don't see anyone's plugs on a rocket ship. They have their own standardization for that, to be honest with you. It's derived from mil-spec. Alright, so this was the company. This was the company that was there. Let's check it out. So, upstaging. Upstaging continuously strives to provide our clients with the latest and cutting-edge technology. Therefore, we are constantly upgrading and rotating our equipment inventory. Tell me something about your company, but also tell me nothing. What does that mean? Wait. All equipment is professionally maintained and in most cases still active in our inventory. Used equipment is subject to availability. Price is subject to change without notice. Does anything there say what the company does? I'm not trying to be mean. Like, maybe rentals? Huh. What? Hang on one second. What part of that said upstaging on it? That thing. It wasn't the unit itself. It was that whatever that thing is. Maybe that's a piece of power distribution equipment, the one with all the plugs on it. Burbaps. Burbaps. Yeah, AV. Interesting. It's important to note that upstagings to, brick and mortar sites are in Los Angeles and Chicago. Neither of those are near Boca Chica at all. So, interesting. Looks like a welding machine thing that outputs electricity. Most welders do that, Swish. Yeah, maybe. I don't know. I don't know what those are. We got one more video to get us up to date on Starship. Let's see what we got. Once again, this is coming from NASA Space Flight. Mary and Nick took this footage. They're down there every day taking this footage. So, yeah, be sure to go over there, sub, so you can see awesome venting like that. That's pretty neat. What's up, staging? Yes. But Hawthorne isn't far. Yeah, that's true. Interesting, God. I've seen a welding machine used to charge a forklift. It worked pretty well, actually. Welders are good at outputting power, Signer, right? And some of them have an extra plug on them. Even the crappy ones do. My crappy welder has a plug on the front. Looks cold. Yeah, that's right, Hellfish. Yeah, they do, don't they? Feels like that scene in the first Back to the Future where the DeLorean goes through and then the cooling loops open and they're like, what is it, hot? No, it's cold. Damn cold. Lawn ornaments. They're working on Booster 5's stand. Huh. Interesting. Huh. Huh. Huh? Huh. Huh. What? I'm thinking. Nice truck. Nice SBMT. Yeah, see that guy that's walking behind it? That's the guy that's driving it. See? Got a little control panel, like a briefcase on the front. Hey, Miata. So that's a saddle for a crane. That's the saddle that goes on the back of a crane that holds counterweights. Said counterweights are right below it. These things. They're like big Legos. 10,000 kilogram Legos. 22,000 pounds per. So, yeah, that's heavy. Weight has nothing to do with it. At least I think that's the saddle. I'm pretty sure. I just got off work. What did I miss? You missed space news. Huh. Fern. You're a saddle. Oh. L's my only weakness. Bullets, my only weakness. How did you know? See the crane with the saddle back there, the Buckner crane? See these little L-shaped thing? That's the saddle. See, it's holding a lot of counterweight. It's got an X on it. That's pretty neat. It was about a week ago. Did you talk about Python Space in their demonstration on how not to test a rocket? Yeah. Yeah, that wasn't a good idea. branding. My brand. Bicycle, bicycle, bicycle. I want to ride my bicycle, bicycle, bicycle. I want to ride my bicycle. I want to ride my bike. Anyway. Bicycle, bicycle, bicycle race. Ding ding. It's an awesome song. That was a tricycle. Shh, it doesn't sound as good. All I want to do is tricycle, and it worked. Works. Incoming copy strike. Yeah. Let's be real. I can't sing as good as Freddie, and therefore, yeah, you don't need to copyright it. It's not even copying it. Are we doing railroads tonight? No, we got racing tonight, dude. Racing. No one can sing as good as Freddie. That's impossible. Hey, wait. What is that? What are these? Are those vents? Are those the vents? Bad piece of satire is what it is? Man, you should stop looking in the mirror. Freaking wrecked! Destroyed! Hello? 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 Yes, please? Yes, I'd like to report a murder. SRB mount points. Cursed. Grab pins? I don't know, Forlorn. Those are attached to the tank. And this is in the center of the booster, because that's the reinforcement for the inner tank. And here's the vents for the oxidizer. So, I'm not exactly sure what those are for. Can't, all the mirrors are broke. That's your response. That's your response. Just take the L. Just take the L and move on. I take L's all the time. Don't worry about it. Yeah, Srishio, I don't know, man. If that's how they want to test, I guess that's their own prerogative, dude. I really don't. Everyone's like so outraged about it. And don't get me wrong, it's not safe. But if that's the way you want to test rockets, I don't know what the heck you could... It's not much you can learn from a rocket's performance if you're dead. Like, because the rocket exploded and killed you. So, if that's their safety culture, I wouldn't be working there. But that's how you want to test stuff. Enjoy. I'll be over here, like, not doing that, you know? Yeah, those are... Yeah, that thing on the left, yeah, that's a vent. I'm not sure what that is. It's got a relief on one side. From what we can tell, they look like the content of a distribution system. Interesting. Huh. All right. A pin for lifting? Maybe, Shex. I'm not sure, but remember, this is in the middle of the booster. That's like between... That is at the very top of the LOX tank, at the very bottom of the methane tank, in the middle of a booster, which is very weird. Yeah, it could be, Mab. Yeah, super heavy mount. Yeah, I saw that. It's got a little... They radiused a piece out of it just a little bit, which is weird. Wait a minute, what the hell? Enhance. 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 That's strange. Sorry. Super Troopers joke. So progressional? Ah, so spellical. So that looks like the same thing, but there's a pipe coming out of the top here. And that pipe is like kind of on a raceway. Raceway are basically corridors that are on the side of a rocket, usually on the outside, because on the inside is fuel, and they usually carry wires and stuff. And I don't think I need to say why you wouldn't want electrical wires being submerged in a fuel tank on a rocket. But yeah, these raceways usually run on the outside. It looks like it's picking up on the raceway right there. But I don't know what this pipe is for. It looks like venting. Usually stuff like this would be at the top of the LOX tank. So venting for something. I'm not sure what though. And why does the vent go up? Huh. Interesting. Safety release? Yeah, well, what's that then? That's a vent line. So what does that one do? Where's that one going? Ooh. New dome. Who dis? Space toilet plumbing. Yes. Yes. My man. Looks like the top needs to be plumbed. Indeed, checks. Yeah. To the LOX header tank? Okay. Yeah, maybe. Let's see that picture, Creeper. Let me see what we got. It's a distribution system. We were just talking about it on Le Padre. So this is a picture that was taken by Mary here. What the hell? That's weird. So this would be at the very, very top of the... This is the very top of the liquid oxygen tank. Right here is the bottom of the methane tank. There's the vents right there. The vents are at the highest point of the tank right there. That's what these vacuum cleaner things look like. Vacuum cleaner? Yeah, well, go vacuum cleaner. It's fine. So these things are basically 90 degrees off of the vacuum cleaner vents. And... yeah, they're connected on pipes on either side, and that pipe goes up. But that's weird. I don't know. Yeah, I don't know what that is. Could be a hard point. A hard point connected to a pipe, goalie? Yeah, I don't know. Dude, I don't have an answer there. I don't know. We're gonna have to wait and see. I'm not sure what it is. They're vents. Well, Zwitch, yeah, I mean, we could say that. For what? It's an idiot confuser. Well, it succeeded in its goal. Wait. Self-burn. I guess is that they'll connect it to the autogenous pressurization system pipes. Going up, Thomas? Maybe. See my last about the new dome piece. Gagan, where... There's something different about the ends of the welds where they cut the piece out of the one they scrapped. Oh, okay. Let's take a look. Oh, they linished it back right here. Interesting. Interesting. Oh, that's cool, Swish. Also spec. Bro, it's 8. That's super late. There's been pipes going up on all boosters so far, and they connect to the top of the LOX tank as well as near the top of the CH4 tank. Yeah. Strange that. Huh. What is the term for you use for when engineers become comfortable with doing something beyond the point of rated scope? Applications, Cornbread? Your above rated performance? Oh, normalization of deviance. Yeah, is that what you're talking about, Cuban? Basically, when you said, I did something that I don't understand. Yeah, whatever, it's fine. Yeah, that's normalization of engineering deviance. Yeah. That's why it's so important to understand the vehicle. Yeah, chat got you on that one. I misunderstood. I misunderestimated your question as. Your question as didn't make any sense. I'm going to have to re-questionize you later when I don't misunderestimate your question. I think that's scrap. I think that's a furred. I swear if someone says that's also scrap, I'm going to kick you right in the teeth. Sheriff, shake hands with danger. Whoa, 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 whoa. What was that? No, just a Camaro. Yeah. Nice Camaro, though. It's not worthy of being scrap. It's lower than that. Why do you talk about your mother that way? That's weird. Also, who scraps humans, Predominant? What the hell's the matter with you? You could say that crane is looking pretty Spartan. Boo! Bird. Only 300 ever made. Tonight, we lift in heck. That is, you know what? That's a really good movie. Yeah, it's a good movie. It's pretty good. I like it. You could say that this job is that crane's Thermopylae. Yes. Yes. Yeah, Kane. It's a good flick. You know, even to this day, I can say I'm going to Leonidas someone, and they know exactly what I mean. Yeah. So those are commodity lines there, and you know, we were talking about SLS's carrier umbilical plate. Well, there's Starships right there. That's Starship's carrier umbilical plate. And these are the gas lines right there for purging, and those are the liquid lines there. But note, a couple of things to note. The diameter of the gas lines for Starship, the purging lines, is a lot smaller than the hydrogen lines. Anybody know why? The gas lines on SLS, the purge lines are like twice the diameter. The liquid fuel lines are about the same. Anyone know why? You would have learned this in the press conference. Think about what propellants SLS is using and what propellants Starship is using. Gaseous methane is more stable than gaseous hydrogen, so you don't need as big of a pipe because you can force it through with more pressure. They need a big pipe, and the flow needs to be a little bit... They need a bigger pipe, and the flow needs to be a little bit different. Obviously, I mean, there's a bunch of different types of flow, but yeah, they can use smaller pipes because methane, more stable. Yeah, Thomas, I see the AP lines. Interesting. It could be a pressure equalization manifold on the autogenous pressurization. I don't know. Not in my personal experience. Going to Taco Bell doesn't count, MCP. Jeez. This is a truck. This is a Tesla. That is a Bomag. Nice, Vin. Yep, see, there's the gas lines for the pad. That's the propellant lines in. Gas lines out. Or I should say gas line out. They don't need to... I don't think they need to go back with the locks. Well, they... Yeah, you could. Or you could just vent it. Oh. Bless you. So they're venting down the tanks there. This is another cryo test. I think they filled it with well, not I think. They filled it with nitrogen, and that was it. That was them venting down the tanks. See? They equalize the pressure with ambient, and the temperature inside goes up, and the condensation melts away. SpaceX allowed to vent methane in critical situations? Yes. Yeah, I mean, if the rocket, as long as it wasn't like on purpose, like, you know, if the thing blows up, yeah, of course you're gonna vent a little bit of methane. But yeah, they don't exactly take it. They don't exactly expect it to explode. You know what I mean? All right, guys, that's all I have for you. That's gonna do it for Space News, and we're right on time for some Friday night racing. We got a bunch of fun races planned tonight. So let's see. I wonder if the first LN2 fill rinses out the junk foreign object to be from the production process. It's purged. Still, they would purge it with, yeah. I mean, yes. Long story short, yeah. It's like back purging a weld, same idea, but just inside of the tank and not welding, obviously. Car question. Have you ever heard of the car brand Lucid? We had one at work today from California. I've heard about Lucid, yeah. Interesting. This video is from a banana factory, so you have to watch it. Wait, racing now? I'm about to eat dinner. I missed the part where that's my problem, bruh. What's up, man? Yeah, well, don't worry. There'll be plenty of racing.